Hello, good morning students. Welcome to this video pertaining to the exam analysis solutions key for the examination which was conducted yesterday, that is Engineering Services Examination 2025, which was conducted yesterday afternoon by the Union Public Service Commission. For the mechanical paper, I am going to discuss the detailed analysis of the paper, key solutions, maybe the what will be the probable cutoff, etc., etc. I would like to detail everything in this video. This is Sekhar from Msigma Gokulam. Okay, so welcome to this video. The exam paper was moderate and easy. I can say the entire, finally the one judgment I can give with all my experience of GATE and IES for the last 30 years, I can give one statement that paper was, rating was moderate to easy, I can say. As compared to the last IES 2024, ESE 2024, this last year also I had given the solutions. As compared to the 2024-2025 paper is moderate to easy. So I can say that final judgment regarding the paper standard as such, this year paper standard, prelims paper. In fact, there were 150 questions, 3 hours time, and the questions are of very peripheral in all these subjects. As you're all aware, the main difference between the GATE examination and ESE examination is in the GATE they would like to test you in detail, in depth, whereas in ESE the questions will be peripheral. And one more major difference is there is an extra syllabus as compared to the GATE in ESE. Particularly, this is the one, renewable energy sources. Renewable energy sources, that is the one in this particular topic. He has given almost 10 to 12 questions. 12 questions he has asked, and another thing is the mechatronics. Mechatronics, also another mechatronics and robotics, that area is again extra. It is not there in GATE, it is there in ES, and also the material science. These three subjects will, which are, in fact, material science is there in GATE also, but only one question. Material science you will expect only one question in the GATE, whereas here he has almost asked more than 10 questions. Total 150 questions, 3 hours time. That means each question will get around 1 minute time. So they will ask only peripheral. And those important subjects pertaining to the GATE like fluid mechanics, heat transfer, thermodynamics, they are not given much here because they have to cover these subjects also. Okay, so that is the only difference. They are not there. No, in GATE examination, these subjects are not there as such. That we have extra in ESE. So those who are preparing for the GATE, they could give the ES exam also, and the standard of the question in the engineering service examination is much easier as compared to the GATE, because in the GATE each question will be, you will be given 3 minutes time and you have to solve the problem. We have to solve all are numericals. In the ESE paper, the questions are theoretical. There is no calculator allowed. In the GATE, calculator allowed. Here ESE, no calculator allowed. So you have to do the calculation manually. So the question will be set in a simpler manner. All the questions are much simpler as compared to the GATE standard. I'm just distinguishing what is the difference between the GATE and the ESE. Those who are preparing for the GATE, they can very well give the ES. Very easily they can give the ES, provided they have to prepare these 3 subjects extra. Because in these 3 subjects are very important in the ESE point of view, which is not there in the GATE. Now let us go in detail to the solutions and key and analysis of each and every question one after another. 150 questions I am going to deal with for the ESE prelims, which was conducted yesterday afternoon between 2 to 5 mechanical paper. So first let me begin with those subjects. Let me begin with those subjects which are given, which are relevant in the GATE point of. First let me do those subjects which are common for the GATE and IES. What are the common subjects? Thermodynamics, heat transfer, fluid mechanics, turbo machines, the production. Actually production, they have given very less number of questions here in this ESE. But whereas in GATE, production will be given around 16 to 17 marks exclusively for the production. So, okay, so there is a certain deviation in the paper setting and paper, question weightage, question depth, question standard in between the ESE and the GATE. Okay, so there are no much number of production questions I have seen in this ESE paper. Now let's see one question after another. First, let me solve those questions which are common between the GATE and the ESE examination. This question, the efficiency of the Otto cycle. Yes, this is the pertaining to the Otto cycle. Air standard cycle, which is IC engine cycle, which will be mostly given in the GATE also. He has given the specific heat gamma is 1.5 and ratio of the specific heats gamma is given. Otto cycle efficiency is given. Very simple question. 1 minus 1 by r to the power of gamma minus 1, where r is called as the compression ratio. Compression ratio. We are all aware that Otto cycle will be PV diagram. It comprises 2 isochorics and 2 isoentropics. 2 isochorics and 2 isoentropics. This compression ratio is V1 by V2, that is CR. We need to calculate the compression ratio. Gamma is given, just substitute that. You will get the what is the compression ratio. I got the answer as 9.85. C is the answer. Compression ratio is equal to 9.8. Very simple, straight question. All the IS questions are straight only, no confusion, no depth at all. Where peripherally they will be given, whereas the gate question needs thinking, needs analysis. You have to deep go into the concepts there in solving the gate problems. A cyclic heat engine operates between a source temperature of 1000 degrees Celsius and a sink temperature of 40. Find the least rate of heat rejection. So in solving this problem, we have to catch up this word least rate of heat rejection. See, in any cyclic heat engine, there will be heat supply, there is a work output, there will be a heat rejection. For a given heat supply, this will be the least, only work output is maximum, obviously this will be the least. That means you have to get the maximum thermal efficiency. That is thermal efficiency is defined as work by heat supplied. For this to be maximum, thermal efficiency to be maximum, to have maximum thermal efficiency, which cycle it should be? Carnot cycle, because there is no other cycle which can have thermal efficiency more than that of Carnot, because it is the highest thermal efficiency as given by Carnot cycle. Therefore, I write the thermal efficiency of the Carnot cycle 1 minus TL by TH, where TL is the temperature of heat rejection, TH is the temperature of heat supply. We all know that Carnot cycle looks like a rectangle on the TS plane. This is TL, this is the TH. Temperature of the heat supply is the TH and the temperature of heat rejection is TL. 1 minus what is the temperature? All the temperatures should be written only in Kelvin. That is 1000 plus 273. Once you get this thermal efficiency of the Carnot, we got this as, we got the 0.754, which should be work divided by heat supplied. What is the heat supplied from this work? How much is the work there? 1 kilowatt work divided by heat supplied, from which we got the heat supplied as 1.326 kilowatts. But he did not ask the heat supply. He has not asked the heat supply, rather he has asked the heat rejection. So again I will bring in from the first law of thermodynamics, we know that Qs minus Q rejection is equal to the work. Heat supply means work is 1 kilowatts, Qs is 1.326, obviously it will be 0.326. Answer is C. C is the answer. Answer is C. 0.326 kilowatts. 1 minus 1.326 is the heat supply. W is the heat power output will be the 1 kilowatts. Heat supply minus heat rejected is work. Therefore, least rate of heat rejection will be 0.326. It is a straight question. To solve this question, we should understand that only the Carnot cycle has got the highest thermal efficiency. In such case only this will be the least, because for a given heat supply only when this is maximum, rejection will be the least. So for this to be maximum, that cycle should have to be Carnot cycle, because only that cycle would have the maximum thermal efficiency. So the question is that we should know that Carnot cycle has got the highest thermal efficiency, and for which the rate of heat rejection will be the least for a given heat supply and for a given power output. Answer is 0.326. 148 question. This is a set D. This question paper is for the set D. So mind that this set D paper. Consider the following statements regarding the Carnot cycle. It cannot be performed in practice because it is impossible to perform a frictionless process. Correct. All the 4 thermodynamic events for the Carnot cycle, all the 4 thermodynamic events for the Carnot cycle are reversible. Reversible. It is the only cycle in thermodynamics which is fully reversible internally and as well as externally. Carnot cycle is the only thermodynamic cycle which is completely reversible both internally and externally. Therefore, no cycle has the friction. No process has got the friction. All the processes are frictionless. Can you achieve such process practically? No. Therefore, it cannot be done practically. Compression and expansion are non-reversible. Wrong. Second statement is wrong. This is wrong statement. It is given non-reversible. All four are reversible. Working medium is a perfect gas and has constant specific heat. Yes, 1 and 3 are the correct. Actually, most of the IES questions resemble the multiple selective questions given in GATE. But in GATE only 3 or 4 questions of multiple selective. Maximum 4 or 5 will be given. But here most of the questions are multiple selective. Almost every question is a multiple selective. There are 2 answers correct. Working medium is a perfect gas and constant specific heats. Mostly the working medium will be the air. Actually, there is some ambiguity in the question. When the cycle itself is not possible to practically achieve, what medium if you use? You can use any medium because it is an imaginary cycle, theoretical cycle, ideal cycle. Actually, one more thing also is there, Carnot cycle. Carnot cycle thermal efficiency is independent of the nature of the working fluid. You use air, you use hydrogen, you get the same efficiency. You use some steam, you will get the same efficiency. Carnot cycle is the only cycle whose thermal efficiency is independent of the nature of the working fluid. Actually, this particular statement is looks redundant and ambiguous also, because Carnot cycle efficiency is independent of any working medium. Use air, use steam, get the hydrogen or nitrogen, you will get the same efficiency, because it depends only on the thermal efficiency of the Carnot cycle, depends only on the temperatures. Is a function of T1, T2. T1 is the high temperature, T2 is the low temperature, and does not depend on anything else. So, but answer is with the question 1 and 3 is the answer. 1 and 3. C is the wrong. Okay. C is the correct answer. A is 1 and 3 is the correct answer. Second statement is wrong. 147 question. Perpetual motion machine. Perpetual means which may not be possible practically. There are 2 perpetual motion machines. One is PMM1, which violates first law, of thermodynamics, which looks like this. PMM1, it is a imaginary heat engine, which produces work continuously without taking heat. So this violates. PMM2 is the one which violates second law, of thermodynamics, because it will convert all the heat supply. PMM2 is this. PMM2, which will convert all the heat supply to the engine completely into the work. This violates second law. This violates first law. This is the PMM1. This is the PMM2. Okay. First one, machine which would continuously absorb heat from a single thermal reservoir and convert heat completely into the work is called PMM2 of the second type. Correct. First statement is correct. Machine which violates the first law of thermodynamics is called the PMM1 of the first kind. Yes, PMM1 of the first kind. Second is also correct. PMM2 of the second kind does not violate the second law of thermodynamics. Wrong. PMM2 violates the second law of thermodynamics. So 1 and 2 is the correct. A is the answer. 1 and 2 is the correct answer. PMM2 violates second law, PMM1 violates first law. Okay, because it is continuously no heat input, but it continuously gives the work output continuously in a cyclic process. Frictionless adiabatic regarding the reversible processes. What is the reversible processes is asked. Frictionless adiabatic expansion is an ideal reversible process. That is, frictionless adiabatic only is called as isoentropy. Frictionless adiabatic, it is a reversible process. Condensation and boiling of liquid are ideal reversible processes, because When the condensation happens on TS plane, temperature remains constant. Condensation, no? This is condensation. Heat is being rejected. But actually, it is only internally reversible. It is not fully reversible. I cannot say the condensation is completely reversible. Change of phase may not be completely reversible, because if this is rejecting heat, there must be some sink which is taking the heat. If there is a temperature difference, again it is externally irreversible. This will be completely reversible only when the delta T between the working fluid and the sink tends to 0. Heat transfer, when the delta T tends to 0, heat transfer, no, then only it is called as externally reversible. So I can say condensation and boiling are internally reversible. If you want to call them as externally reversible, what is boiling? Change of phase from liquid to the vapor. So this is a boiling phenomenon where heat is supplied. So again this can be called as completely reversible only if the temperature of the source and the temperature of the working fluid are equal. So heat transfer with delta T tends to 0, then only it can be called as externally reversible. But IAS questions are somewhat peripheral. We have to understand the examiner's mind and go with the answer. He means that it is reversible only. So 1 and 2 are correct. Mixing of two fluids is it? No. Mixing of two fluids is an irreversible process. 1 and 2, A is the answer. When you mix two fluids, this is nitrogen and this is oxygen. If you remove the chamber, nitrogen will diffuse and oxygen will diffuse like this, and that mixing is definitely irreversible process. It is irreversible. It is not reversible. Right. Answer is A. Regarding the first law of thermodynamics. So thermodynamics has asked a good number of questions. In a gate also you may expect around 6 to 6 marks. Average weightage for the gate in thermodynamics is 6 to 7, sometimes 7, sometimes 6. Usually 6 marks minimum we give it. The first law applies to reversible as well as irreversible transformations. Yes, first law of thermodynamics, it is valid for any process, any thermodynamic process. See my videos, the videos I had given in thermodynamics classes. I had told you this equation is valid for any thermodynamic process. It is impossible to construct a perpetual motion machine of the first kind. Yes, perpetual motion PMM1 violates the first law of thermodynamics. It is impossible to correct. Yes, 1 and 2 are correct. When a system is made to undergo a complete cycle, then the network is done on or by the system. Yes, there is a thermodynamic cycles which runs on the clockwise cycle. Here in this case, cyclic integral of delta W or network done is positive. Like example, heat engine cycles. All heat engine cycles like Otto cycle, diesel cycle, Brayton cycle, like example, no, Otto, diesel, Brayton. They're all the heat engine cycles which produces the work. On the other hand, if you take the cycle on the PV plane which runs in the anti-clockwise sense, here cyclic integral of delta W is equal to negative work absorbing cycle or power absorbing cycle. I clearly mentioned in my videos also, thermodynamics videos. Example is refrigeration, vapor compression, VCR cycle, vapor compression refrigeration cycle. All the refrigeration cycles, heat pump cycle, they are all the work absorbing cycles. So work will be negative. So answer, all the three are correct. Answer will be D. All three are correct. If it is a clockwise cycle, it is called heat engine cycle. If it is an anti-clockwise cycle, look at the arrows there. It is an anti-clockwise cycle. Therefore, it is a work absorbing cycle. The machine requires work. It won't give you the work, it requires work. For example, refrigeration cycle, heat pump cycle, and air conditioning cycles. They are vapor absorption cycle, vapor compression refrigeration cycle, heat pump cycle. They are all the power absorbing cycles, where we need to do work on the machine. You need to supply the power to the machine. So answer will be all the three statements are correct. It is also regarding the thermodynamics. Following statements pertaining to the thermometer and thermometric property. Constant volume gas thermometer used to measure resistance. No, there is no link there. Constant volume gas thermometer, it works on the Charles law. Actually, this works on the Charles law. Charles law of ideal gas. Ideal gas thermometer is also called, which says that when volume is constant, pressure is directly proportional to the absolute temperature. So thermocouple is used to measure the electromotive force. Actually, thermocouple, it is a temperature measuring device. It is used for measuring the temperature of the gases. When two different materials are made a junction, and it is generally hot fluid temperatures it is mentioned, it is called as a thermocouple junction bead. When it is subjected to high temperature and the other mode is subjected to the low temperature, it is also called as the Seebeck effect. It works on, the thermocouple works on the principle of Seebeck. Okay, there is a EMF generated. If these two are at a T1 and T2, there will be a EMF generated. This effect is only called as Seebeck effect. That is a principle of measuring the temperature by using the thermocouple. Couple means two dissimilar wires which are maintained by junctions. If these two junctions are made at two different temperatures, there is a EMF generated. There is a EMF generated. T1, T2. T1 is not equal to T2. That is a, so thermocouple is a pyrometer is used to measure the intensity of radiation. Optical pyrometer, high temperature measurement. Pyrometer is for the very high temperature measurement by using the radiation. High temperature measurement. Pyrometry, optical pyrometry, it works on the radiation heat transfer, radiation phenomenon, whereas the thermocouple works on the thermoelectric effect, which is also called as the Seebeck effect or thermoelectric effect. And first one is a constant volume gas thermometer, is ideal gas thermometer. By using the absolute zero temperature is minus 273.15 degrees Celsius, absolute zero temperature. Constant volume gas thermometer works on the Charles law of ideal gas, whereas the pyrometer is meant for the high temperature measurement. Third one, okay, third statement. 2 and 3 are correct. Answer will be B. Okay. Ideal gas thermometer, constant volume ideal gas thermometer doesn't have anything with the resistance there, right? 2 and 3 are the correct. Thermocouple also meant for measuring the temperatures of the hot fluids flowing in a duct. This is a thermocouple junction. There is an EMF generated if there is a two junctions are maintained at two different temperatures. This effect is called Seebeck effect, which is a thermoelectric effect. Phase change of a pure substance, difference between the superheated temperature and this is a question based on the pure substances. Difference between the, this is the saturation temperature, this is the superheat temperature, this is the saturation temperature. This difference is called degree of superheat. Yes, correct. One is correct. The amount of heat required to convert liquid water into vapor is called as the heat of sublimation. No. Sublimation is the process where the solid directly becomes into the vapor. Solid CO2, dry ice refrigeration, which is also called as the dry ice refrigeration, is an example for this sublimation. Conversion of solid to the vapor directly without any intermediate liquid phase, that is called as a sublimation. He is asking liquid to the vapor. No, wrong. That is, it should be the solid to the vapor. Best example is CO2, solid CO2, which is also called as the dry ice refrigeration. If the temperature of liquid water on cooling becomes lower than the saturation temperature for the given pressure, the liquid water is called as a subcooled liquid. Yes, this is the superheating. This is called as the subcooling on the temperature entropy diagram. This process is called as the subcooling. this temperature difference is also called as the degree of subcooling. If this is called degree of superheating temperature, this is called as the degree of superheat. This temperature difference, this is called as the degree of subcooling. The temperature of the liquid is lesser than the saturation temperature of the liquid corresponding to its saturation pressure. Okay. So what is the saturation temperature? Where the is a isobaric line. This is a constant pressure line. What do you mean by saturation temperature? It is a temperature change at which the change of phase happens from liquid to the vapor or from vapor to the liquid. This change of phase is called boiling, and this change of phase is called as condensation. Okay, these are the general terms pertaining to the pure substances. In the refrigeration cycles you see, in the Rankine cycles you see. Okay, so if the temperature of 1 and 3 are correct, that is 1 and 3, C is the correct answer. Regarding the pure substance, it is homogeneous in composition, it is homogeneous in chemical aggregation, it is variable in chemical aggregation. 1 and 2 are correct. A. What is a pure substance? It should have the uniform chemical composition throughout. Its chemical aggregation must be uniform everywhere, not that at one corner. Supposing if you have the pure substance, here, everywhere you should have the same chemical composition. Chemical aggregation is uniform throughout. That is called as a pure substance. Answer is 1 and 2. Regarding a thermodynamic system, closed, it is not closed. Closed system is that in which exchanges neither energy nor matter. Wrong, this is. Closed system exchanges energy. There may be heat transfer, there may be work transfer, but there is no mass transfer. Work transfer may be there, heat transfer may be there, but it is giving neither energy nor matter. So answer 1 is wrong. 1 is wrong. A system which consists of two phases is called as a heterogeneous system. A phase is a quantity of matter which is homogeneous throughout in chemical composition and physical structure. 2 and 3 are correct. B is the answer. 1 is wrong. Because it is a closed system, only mass transfer is not there, but there will be energy transfer between the system and the surroundings. It is called as the closed system. 2 and 3 are correct. Two phases is called as heterogeneous. A phase is a quantity of matter which is homogeneous throughout in chemical composition and physical structure. So that is 2 and 3 are the correct. Dry bulb temperature is all questions asked in the R&DC. See, the refrigeration, thermodynamics weightage, if you just see in all the previous questions, he has almost asked 9 to 10 questions. See how easy the thermodynamics questions are in ESE, but whereas in GATE, thermodynamics questions are not that easy. You will ask a problem, you will set a problem there, and which you have to complete in 3 minutes. Here you see, each question may not be taking around 30 seconds. Just by reading the problem you can answer 30 to 35 seconds. There 3 minutes of time will be there for the GATE. So with 3 minutes allotted time, definitely most of the people will cross 3 to 4 minutes because it is a problem. So there is a vast difference in the paper, question quality, question depth, there is a good difference. But the problem, the main thing about the ESE is the syllabus is vast, more number of subjects, but all the subjects you will touch peripherally only. But GATE, less number of subjects as compared to the ESE, but they go in deep. So I can say if you prepare for the GATE, well, all the relevant subjects in IES, within seconds you can answer the questions. See this question. A dry bulb temperature is the temperature of the air measured with an ordinary thermometer. Yes, correct. DBT is the temperature measured by an ordinary thermometer whose reading is not influenced by the moisture present in the air. I repeat once again, DBT is the temperature recorded by an ordinary thermometer whose reading is not influenced by the moisture present in the air or by thermal radiation. So that is the definition of the DBT. Correct. Dew point temperature is the temperature at which the water vapor in the air is saturated. Yes. Dew point temperature, supposing if this room is there. If I keep on cooling this room at one particular temperature, there will be a condensation of the water vapor starts. Condensation of the water vapor just begins. that temperature is called as the dew point temperature. Yes, at which once you reach the dew point temperature, the water vapor becomes saturated, therefore it starts condensation, actually becoming into the liquid. So second is also correct. Sensible heat is necessary to produce a change of state of a material at a constant temperature. No, it is called as a latent heat. It is not sensible heat, rather it is a latent heat, not sensible heat. So dBT is correct, dPT is also correct. So 1 and 2 is the answer, A is the answer. dBT is the temperature recorded by an ordinary thermometer whose reading is not influenced by the moisture present in the air. Whereas dPT is the temperature, if the room air is there, there is a water vapor is there. So if you keep on cooling the room air, so imagine that at constant pressure, there will be a water droplet appears, first water droplet appears. This is called as a dew. So it is a saturation temperature corresponding to the existing humidity ratio and barometric pressure. Dew point temperature is the temperature at which the water vapor in the air is saturated, therefore it just begins to condense from vapor phase to the liquid phase. 1 and 2 are correct. The sensible heat gain of a room is 4.8 and latent heat gain is sensible heat factor. Actually sensible heat ratio is given, more correctly it is called as sensible heat factor, which is the SHF, which is given as sensible heat divided by sensible heat plus latent heat. What is the sensible heat gain? 4.8 divided by 4.8 plus 1.4. 4.8 by 4.8 plus 1. I think 0.7. You will get one of those answers. I think 0.77. There are two sensible heat factors in the AC, air conditioning. There is a question on air conditioning. Room sensible heat factor, gross sensible heat factor. Particularly in the ESE mains, this is a prelims exam. ESE mains, 15 to 20 marks question, solid question will come from the refrigeration air conditioning. 15 to 20 marks minimum. One solid question main in the ESE mains you will get. Okay, where the two sensible heat factors we may have to use in that conventional question. Room sensible heat factor, gross sensible heat factor, and you have to use the psychrometric chart, etc. And in this year GATE 2025, he has asked one question on the psychrometric chart. One question, but a very simple question. What is the x-axis on the psychrometric chart he is asking? That is a dry bulb temperature. Y-axis is the specific humidity. Actually, only one question is asked RNDC this year GATE, but that is a very straightforward question, very quite easy. Actually, this year GATE 2025 also very easy paper as compared to the last year. This ESE 2025 also easier as compared to the ESE paper 2024. Following properties regarding the moisture, it is also a question of the air conditioning. Percentage saturation is defined as the ratio of specific humidity saturated versus actual at a given temperature. Yes, but this is also called as the degree of saturation. He has given percentage saturation, it is called degree of saturation mu. W actual divided by W saturation. This is, what is this W? W is the humidity ratio. Humidity ratio or specific humidity. So first one is correct. Specific humidity is defined as the mass of water vapor in kg which is associated with 1 kg of dry air water vapor mixture. Specific humidity is defined as the mass of water vapor in kg which is associated with 1 kilogram of dry air water vapor mixture. Yes, actually more it is an ambiguous statement. Specific humidity W has got the units of kg of water vapor per kg of dry air. It should be calculated like this. Supposing in a container, if MA is the mass of dry air and if MV is the mass of water vapor, specific humidity is given as MV divided by MA. But if you just look at the statement here, associated with 1 kilogram of dry air water vapor mixture, that is wrong actually. It is the water vapor associated along with 1 kg of dry air in a mixture of dry air and water vapor. So This 2 statement is wrong. See, look at the units there, kg of water vapor per kg of dry air. But if you look at this statement here, per kilogram of dry air water vapor mixture, total mass of the mixture he has taken 1 kg, that is wrong statement. First statement is correct. Relative humidity is ratio of actual water vapor pressure in the air to the vapor pressure which would exist in a saturated mixture at the temperature of the air. Correct. Relative humidity is PV by PS at the same dry bulb temperature. This is RH 5 relative humidity. So, first statement and third statement are correct. Answer is C. Second statement is wrong. Actually, this wording is bad, not correct. 1 kg of dry air. If you ask up to there, if you have stopped, that statement would be correct. But 1 kg of dry air water vapor mixture he is asking. So, look at this. MA is the mass of dry air. This is the mass of dry air. MV is the mass of water vapor. Mass of water vapor divided by mass of dry air. That is the definition of the specific humidity. But he has asked per kilogram of dry air water vapor mixture. Total mixture mass he has considered. Wrong. 1 and 3 are correct. This W only is seen on the psychrometric chart on the y-axis. You can look at that psychrometric chart also. Kg of water vapor. You look at the units there. Per kg of dry air. X-axis will be dry bulb temperature. This is the psychrometric chart. Answer will be C. See, if R&AC is asking almost 7 to 8 questions here in ESE, but in GATE you may expect maximum 1 question. Maximum 1 question only. We will not expect more than that in GATE. See, there are certain subjects which are more important in GATE. There are certain subjects which are more important in ESE, but there are certain subjects which are more important in both the exams. Like for example, thermodynamics, for example, fluid mechanics. They are very, very important in both ESE and GATE. Okay. Heat transfer. Actually, heat transfer this year has come lesser in ESE, but in GATE they will ask more. But heat transfer many times in ESE also it will be more. But this year they are not asked much, but I will show you how many has asked. Let us count there. Vapor absorption cycle. Absorbent should have negligible vapor pressure at generator temperature compared to the refrigerant. Yes, correct. Generally in the VAR systems, we have 2 examples there. In the VAR system, examples will be aqua ammonia, aqua ammonia, NH3. Here NH3 is the absorbent, water is the, NH3 is the refrigerant, water is the absorbent. Aqua means water, is the absorbent. There is one more example is there. Lithium bromide, LiBr VR system. Here refrigerant is water, lithium bromide is a absorbent. Salt is absorbent. Lithium bromide salt has got the issue, it has got a good affinity towards the water. Water is a refrigerant, lithium bromide is absorbent. Here water is the absorbent in aqua ammonia and refrigerant is ammonia, NH3. Okay, 2 different systems are there. Both work on the, there is one more also, Electrolux. Electrolux also is there. They are also 3 fluid system. It is a 3 fluid system. We have the H2O, water, we have the ammonia, we have the hydrogen gas. 3 fluid system, that is called Electrolux. 3 examples I can give for the vapor absorption refrigeration systems. Absorbent should have low vapor pressure, negligible vapor pressure, correct? And absorbent should have low specific heat, that is also correct. And lithium bromide is a hygroscopic salt with low affinity for water, wrong. Lithium bromide has got a more affinity, more attractive for the water. Therefore, that is why it can easily absorb the water. Lithium bromide salt is good absorbent, therefore it has got more affinity for the water. 1 and 2 are correct. A is the answer. Questions are very peripheral, theoretical. Just by reading the question, if you know the concept, you can put it. If you don't know the concept, you cannot answer even if you wait for half an hour also. So, absorbent should have the low vapor pressure at a generator temperature, because whatever the function that is performed by VCR, compressor and VCR, it is performed by 4 components in VAR: absorber, pump, generator and reducing valve. Vapor compression system, vapor absorption refrigeration system, the main difference is in the VCR system, the main part of the energy input will go in the form of the mechanical shaft work. In the vapor absorption refrigeration system, the main part of the energy input goes in the form of the heat energy. So, in the vapor absorption refrigeration system, you are using the low grade thermal energy as the energy input, whereas in the VCR system, you are using the shaft mechanical power. High grade mechanical work is used as the energy input in the VCR system. That is the main difference between VCR and VAR. But most of the refrigeration systems, what we see in our day-to-day life, in our domestic refrigerator, window air conditioner, in the water cooler, what you see in the water coolers, you see, no? Everywhere you see the water coolers, they all operate on VCR systems only. VAR systems are preferred for the large tonnage units, above 600 tons, 700 tons only, they prefer the VAR systems, and also where the mechanical shaft work is scarce. There is a scarcity of the mechanical shaft work, then they go for the VAR system, where the energy input is in the form of the heat energy. We can burn the fuel and use that heat as the energy input to the VAR system. So, these are the 3 examples. Aqua ammonia, aqua means water, aqua ammonia, lithium bromide and Electrolux. In all the things, here the absorbent is water, here and first and last. NH3 is the refrigerant. In the second one, LIBR, refrigerant is water, but absorbent is lithium bromide salt, which has got a good affinity. Affinity means attraction. So, that is more for the lithium bromide, but he has given the low affinity, so third is wrong. 1 and 2 are correct. Again, the properties of the refrigerant. See how many questions he is asking about the ammonia is highly toxic and highly irritating refrigerant. Correct. Ammonia is first statement is correct. But ammonia advantage is, main advantage of ammonia is highest latent heat of vaporization. Among all the refrigerants, highest latent heat of vaporization is for the ammonia. That is why ammonia is generally preferred for the large tonnage units. But ammonia is toxic and pungent smell, very strong, pungent and highly irritating smell you will have this. One is correct. Carbon dioxide is a corrosive refrigerant. Wrong. Sulfur dioxide is highly toxic. So, SO2 is highly toxic and corrosive also. Sulfur dioxide is a refrigerant, highly toxic and corrosive. So, 1 and 3 are correct. C. This question is pertaining to the refrigerants. Particularly inorganic refrigerants. They are all called as inorganic refrigerants. There are organic refrigerants are there. R12, R113, R134. They are all the organic based. So, methane based, ethane based. All the commercially available refrigerants are organic refrigerants. Some are methane based, some are ethane based. But problem is some of them will deplete the ozone layer. But nowadays people are finding out new generation refrigerants like R134. In your house there is R134 being used. In your car also. That is a environment friendly refrigerant R134A. Which is again a ethane based refrigerant. These are all the inorganic, ammonia, carbon dioxide, sulfur, they are all the sulfur dioxide, they are all the inorganic. Answer is C. What type of turbulence is generated by 2 adjacent layers of fluid in the absence of wall? Free turbulence. If there is no wall, particularly this is used in the wind tunnel equipments, apparatus, wind tunnel apparatus or where the high velocity fluid, free turbulence without the influence of the solid boundary. If any turbulence is created without the influence of the solid boundary, that is called as the free turbulence. Generally in the wind tunnel apparatus on the aerodynamic, for the aerodynamic equipments, like this is suppose aircraft is flying in the air. This turbulence between the fluid layers, eddy turbulence, will cause the problem while the flight is flying also. Then the weather becomes very rough and it will cause the unnecessary troubles to the flying of the aircraft also. You would see in the news also many times, many aircrafts will feel the turbulence. the turbulence without the influence of the solid boundary. What is there in solid boundary in air? Aircraft is flying at the height of 10,000 feet or 20,000 feet, but there is no solid boundary, but still there is a turbulence there between the, that is called as a free turbulence. See, all these questions are regarding the fluid mechanics. Let us check how many fluid mechanics is asked. Previous also fluid mechanics. Predicted that the waves would form and grow in the boundary layer. This question is regarding the boundary layer. Whenever there is a flow happening place, is a laminar flow. What is a transition? Transition is neither laminar nor turbulent. It is a conversion, shifting. Laminar, turbulent. Here slowly the flow will becoming transitional. Here complete intermingling. This is the flow will become completely turbulent. That is true in the, supposing if the flow is happening in a pipe, this is the laminar flow. If this is the laminar flow, in the pipe, this is the transition. Transition happens like this, slowly turbulence begins. In the pipe, if it is a continuous intermingling, this is the turbulent domain. Okay, this is laminar, this is transition, this is turbulent. Internal flows, if the flow is happening like this, that is external flow over flat plate. Tolman and Skittling has predicted that the waves would form and grow in the boundary layer. Yes, one is correct. In the presence of an adverse pressure gradient. What do you mean by adverse pressure gradient? dP by dx greater than 0. It is called as adverse pressure gradient, which is responsible for the flow separation. Adverse pressure gradient is responsible for the boundary layer separation, flow separation or boundary layer separation. In the presence of at a high Reynolds numbers, two-dimensional waves appear. Yes, two-dimensional waves may appear because the flow may get separated. What do you mean by adverse pressure gradient? In the direction of the flow, the pressure is increasing. Generally, that would happen when the flow is happening over a cylindrical bodies or a spherical bodies. If the flow is happening like this, if it is a curvilinear body, flow over a curvilinear body, yes, there may be chance of the two-dimensional waves may appear there. So, that in this case, here the dP by dx is 0 for a flow or flat plates. Look at my fluid mechanics videos I had given very clearly in the boundary layer theory. I mentioned that this adverse pressure gradient would exist only in case of the flow over curved bodies, not over the flow over flat plates. In flow over flat plates, there is no adverse pressure gradient, so there is no chance for the boundary layer separation. Boundary layers have dP by dx greater than 0 is only necessary condition, may not be a sufficient condition to cause the boundary layer separation. This adverse pressure gradient is a necessary condition, but not a sufficient condition to have the boundary layer separation. It would happen usually when a flow happens over a curvilinear bodies. When the decelerating and accelerating flow, in such cases you would have this. I told you the example also in the venturimeter, why you keep the diverging portion very long in length. As compared to the converging, diverging portion is kept long in length in the venturimeter. The reason is to avoid this flow separation, because in the diverging portion you would see this adverse pressure gradient. Adverse means not favorable. In the direction of the flow, pressure is increasing. So that is called as the adverse pressure gradient. If x is the direction of the flow, in that direction if the pressure is increasing, it is a adverse pressure gradient. But in flat plate, for a flow over flat plate, dP by dx is greater than is equal to 0. The instantaneous velocity profiles produce low shear in the outer region of the boundary layer. Yes, in the outer region, see outside this hydrodynamic boundary layer, everywhere the free stream velocity is only Vc. Everywhere free stream velocity is only C. The instantaneous velocity profiles low shear in the outer region. Whatever the, here also you would see the laminar sublayer and laminar sublayer velocity profile may be there. So, but in the instantaneous velocity profiles produce low shear in the outer region of the boundary layer outer region, very low viscous stresses you will be seeing. So, answer will be 1, 2, 3. D is the answer. All three statements are correct. In the transitional flow, the disturbances grow in size, and once you enter the turbulent region, the flow would become completely turbulent, where in the turbulent region local Reynolds number is greater than 6.5 into 10 power 5. In the laminar region, local Reynolds number is 5 into 10 power 5, less than that, less than the 5 into 5 lakhs, less than 5 lakhs. Here greater than 6.5 lakhs to 7 lakhs. In between, the flow is in transition. This is the flow is in transition. Transition means what? Shifting, like this. For flow through pipes, you can see this wavery nature of the dye color. Okay, this is a turbulent flow. This is a laminar flow. So the boundary layer theory, as I said in my video classes also, you may expect a good number of questions in GATE and ESE also regarding the boundary layer theory. It is initially you may feel that boundary layer theory is tough, but once you enter the topic and try to understand them, all the problems you could easily solve once you get the hold on to the fundamental concepts of the how a boundary layer forms and grows. Which type of glass is used in the flat plate collector? This is again a material science question. You see, material science is a very good number they will ask every ESE, minimum 10 questions. But in GATE you will expect only one question. Only one question, not more than one in GATE, but here they will ask around 8 to 9 to 10 questions here in ESE. Low iron tempered glass. Generally, low iron in glass means high transmissivity. High transmissivity for the solar radiation. High transmissivity. Now, transmissivity is the property in a tempered glass, high transmissivity tau. Generally, in the solar flat plate collector, if this is the absorber plate, there will be transparent covers will be there. When the solar radiation comes, this glass, cover glass, it should have the more transmissivity so that the energy could easily fall there. This is an absorber plate. This is an absorber plate. It is a question on the renewable energy and material glass. So this should have the more transmissivity, and the energy should not go back into the air. So it will trap the energy. So that will low iron tempered glass will have high transmissivity, and also when it broken also it won't damage the solar plate, because it will, even if it is broken, it will get into small granules, so it won't damage the absorber plate. Absorber plate should have the high alpha, high absorptivity, whereas this glass cover plate, this glass cover should have more transmissivity. Answer is A. What is the pressure gradient along the flow if the oil viscosity? It is a question based on the two fixed plates. There is a flow happening. It is a parabolic velocity distribution, right? It is a parabolic velocity distribution. If this is y, if this gap is d, u is given by minus 1 by 2 mu, this is x direction, this is the flow direction, this is the x direction, 1 minus 2 by dou p by dou x into dy minus y square. This is the velocity profile. This is the y direction, this is the x direction. U is the velocity at any distance, Okay. He has asked one, d is given as 10 mm. Stationary pile plates 1 meter wide, the velocity midway between the plates at y is equal to d by 2, velocity is given as 2 meters per second. D is the gap between the plates, two fixed plates. It is the flow between two fixed plates. It is a fluid flow between two fixed plates. Actually, there are three kinds of flows I can say here. Three different types you may see. If there are one plate is fixed and there is another plate is moving with a constant velocity. There is in between the plates you have a fluid. There are two plates, one plate is fixed, there is another plate which is moving with a constant velocity in this direction. The gap between the plates is filled with the fluid. Such kind of a flow is called as a cohesive flow. It is not cohesive flow because here both the plates are fixed. If the one plate is moving with a constant velocity and bottom plate is fixed, it is called as a cohesive flow. There is another type of flow where the flow through a pipe, a constant cross-sectional area pipe, that is called as a Poiseuille flow. So, where we know the velocity varies parabolically, shear stress varies linearly with respect to the radial distance, we all that know that. Here, if y is a coordinate here, u is a u function actually with respect to y, and minus dou p by dou x is the pressure gradient. It is a pressure gradient in the direction of flow. Pressure gradient, we need to calculate that. The pressure gradient, what is the pressure gradient? We have to calculate, for which you know the d is given as 10 mm. So, I need to substitute at y is equal to d by 2, you just keep it there. What is the u value given there? U value is given as 2 is equal to minus 1 by 2 mu dou p by dou x. Put y is equal to d by 2. D into d by 2 from that velocity distribution minus d by 2 whole square. Okay. And the mu value is also given. Viscosity of the oil is given as 0.02. Mu is given as 0.02 Newton second per meter square, Pascal second. If you substitute all this, the dou p by dou x will get as minus 3200, implies dou p by dou x is minus 3200 Pascal. Answer is C. Mu is given as 0.02 Newton Pascal second. So, it is a parabolic distribution. D is the gap between the plates, y is the y coordinate measured in this direction. Generally, this only once he has asked this question in GATE. Most of the questions in GATE, particularly on this topic, will be asked about the cohesive flow. Cohesive flow, you know what is a cohesive flow? Cohesive flow, that is one plate is fixed, but the top plate will be moving with a constant velocity u or v. So, this is the most commonly asked. Another asked will be flow through constant area duct. This is also called as the Poiseuille flow. Most of the GATE questions they asked about these two things. Here the linear velocity profile, here again the parabolic velocity profile. So, remember these two are commonly asked in GATE, but here it is a flow between two fixed plates here. You should be able to compare the question depth between ESE and GATE, what is focused more there, what is focused here, what is commonly focused in both the exams, because one exam is complementary to the other. If you prepare for the GATE, ESE will become very easy, very easy in those subjects which are common, but you have to prepare extra subjects for the ESE. Here is very simple question, venturimeter. CV into velocity is CV root 2 GH. It is a formula for pitot tube. You know very well. I have done a good number of problems in my FM classes also pertaining to the GATE. Orifice meter A, CD, A0, A1. CD, A0, A1 root 2 GH by square root of A1 square minus A2 square. This is for the orifice meter, where A0 is the area of the orifice plate. What is orifice? It is a thin plate thin plate where the fluid gets accelerated because like this. This is called vena contracta. This minimum area of cross section is called as vena contracta. So by taking the pressure tappings between this point and this point upstream, you will get the discharge. A0 is the area, this area is A0. A1 is the area at upstream of the plate, okay, that pipe, diameter of the pipe, that is A1. And CD into A1 A2 by root of A1 A2 root GH by A1 square minus A2 square is the venturimeter. So P will be the orifice meter, P will be the 3, Q will be the 1, petard tube, R will be the 2. This is the matching, correct matching. Orifice meter, venturimeter, petard tube. I have very clearly discussed in my fluid mechanics classes, in the gate classes also. You can see all the 3 formula there. But usually coefficient of discharge for the orifice meter is 0.63, much lesser than the coefficient of discharge in the venturimeter. In the CD in the venturimeter, CD is the, here for the orifice meter it will be around 0.63, whereas for the venturimeter it is around 0.98. Coefficient of discharge for the venturimeter is 0.97, 0.98. If the velocity, yes, this is a very important topic in gate point of view, very important topic. Most important topic of FM in gate will be fluid kinematics, velocity potential, stream function, 2-dimensional flow, streamline, path line, etc., etc. No, irrotationality condition. All these things will be definitely asked in the gate. Velocity potential phi exists, it should be rotational. Wrong. If the phi exists, it is called irrotational. One is wrong. First statement is wrong. If velocity potential phi satisfies the Laplace equation, that is del square phi is equal to 0, this is a Laplace equation, it represents a possible steady incompressible irrotational flow. Yes, 2 is correct. 2 is correct statement. If the stream function psi exists, it is a possible case of fluid flow which may be rotational or irrotational. Correct. Third thing is also correct. Psi is the stream function. If psi is existing means, as it means that yes, your continuity equation is satisfied, your flow is existing. If psi is existing, a flow is existing. If the phi is existing, velocity potential phi existing, that flow is irrotational. The condition for the irrotationality is that velocity potential function phi exists only for the irrotational flows. That is why irrotational flows are also called as potential flows. Irrotational flows are also called as potential flows because the phi satisfies the Laplace equation. If phi is existing, flow is irrotational. If psi is existing, if the stream function is existing, the continuity equation is satisfied, therefore there must be some fluid flow existing. Right. 2 and 3 are correct. Answer is B. These are very clear, very simple. Steady uniform flow means flow at constant rate through a duct of uniform section. P will be 2. Steady non-uniform flow, constant flow rate, flow at constant through a duct of non-uniform cross section. Q is 4. Unsteady uniform flow, that means flow rate is not flow at varying rates through a long straight uniform cross section. R is 1. Rest will be S will be 3. If the long duct with a constant mass flow rate, it is steady uniform. Uniform means what? Having the same velocities at every cross section at a given instant of time. If you see the same velocities at every point, it is called as a uniform. If the things are not changing with respect to time, if the velocity at a point is not changing with respect to the time, it is called as a steady flow. Okay. Supposing if it is like this, mass flow rate is constant. It is a steady but non-uniform. Why non-uniform? Here the velocity V1 is not equal to the velocity V2. At any instant of time, this velocity is more. This velocity V2 is more than V1. V2 is not equal to the V1. It is a non-uniform, but flow is steady. So you should understand that. Okay. difference between steady and unsteady, uniform and non-uniform. Uniform means at every location you should see the same velocity. Steady means at a particular point the velocity must not change with respect to the time. No variation with respect to the time, it is called as a steady. All these questions are fluid mechanics only. Consider the following regarding the floating bodies. Ship or boat. This is the floating body. Submerged body means balloon, submarine. The conditions of equilibrium in the buoyancy and flotation chapter will be two different situations you see. One is a floating body, ship or a boat. Submerged body means a balloon in air or a submarine. Generally in the war times they use the submarine, right? So we have the submerged body. During the movement, the volume immersed on both right hand side and left hand side increases. No. Supposing if this is a submerged body, if it is a submerged body, after the body got displaced, after giving a slight angular displacement, it will displace more liquid on the right side. It will displace more liquid on the right side as compared to the left side. It is initial position. After tilting the body, after giving a slight angular displacement, the body is displacing more liquid on its right side. So on both right hand side, volume immersed on both right hand side, left hand side increases. No, only right hand side increases. One is wrong. The angular displacement of a boat about its longitudinal axis, it is known as rolling, correct. Angular displacement about, supposing if this is a ship, if there is a ship, if this is a water, if this is the longitudinal, if you see from the top, this is the longitudinal axis. About the longitudinal axis, if it is taking the rotation like this, it is called as a rolling. About the transverse axis, if this is a transverse axis, about this, if it is going up, if it is going down, that is called as a pitching motion. If the ship is going like this or going like this is called as a pitching. On the other hand, if you see from the side view, if the ship is rolling like this because the tide is hitting like this, if this kind of a motion is called as a rolling. 2 and 3 are correct. B is the correct answer. Supposing if this is a ship, going, if the ship is moving, rotating, is sliding, about the longitudinal axis, it is rotating like this, it is called as a rolling motion. If the ship is moving like this, if it is moving like this, about the transverse axis, it is called as a pitching motion. Pitching motion, it is very difficult, it is difficult for the ship. Pitching is not a dangerous motion. The ship will not get tilted, but for the rolling motion, it may get tilted up easily, overturned like. So ship design must always be keeping the rolling motion in mind. Okay. This motion, if the ship is like this, ship is traveling like this. If it is moving like this, because it is rotating, it is having a angular displacement, it is like this, it is called pitching. If it is displacing like this, it is called as a rolling. Rolling motion is dangerous for overturning. Which principle is basis for the differential pressure measure? Torricelli's. Bernoulli's is no way. Bernoulli's is differential pressure measuring devices. No, YouTube manometer. Differential pressure measuring devices. 2 points. Euler's continuity is the basis for differential pressure measuring devices. It will be like generally if you venturimeter means Bernoulli use continuity, you will use that. But if you want to if you use the differential pressure measuring devices, 2 locations, what is the difference means? This is X. That is P1 minus P2 by W is equal to X into Sm by S minus 1. This is what is asked, that is a Torricelli's formula. A pipe contains oil of specific gravity 0.9. S will be 0.9. Okay. At 2 points A and B, a differential manometer is attached. Okay. the pressure difference, level difference in mercury is 15 centimeter, which can be taken as x. This oil has got a specific gravity, this has got the manometric liquid has got 13.6. PA minus PB by W is equal to x into SM by S minus 1, implies PA minus PB is equal to W into x into SM by S minus 1. This is a formula, this is a manometric equation, right? Pressure difference between these 2 points. The flowing liquid is oil. Between 2 points, you need to know the pressure difference. It is a mercury. Mercury has got a specific gravity of 13.6. W, no, that will be equal to W will be 0.9 into 9.81, 9.81 into 10 cube. X will be 15 by 100 into 13.6 by 0.9 minus 1. So you will get 18688. B is the answer. Pascal. W of the oil is equal to W of S of the oil into W of water. What is W of water? 9.81 kilonewton per meter cube. Convert into the Newton per meter cube by multiplying with 10 cube. S of the oil is 0.9. Flowing thing is oil. This is mercury. This is mercury, right? 13.6. Simple question. So many questions are asked in the FM also, almost 8 to 9 questions in the fluid mechanics. Upon cooling, a liquid phase is transformed into the 2 solid phases alpha and B at the same temperature. The opposite reaction occurs upon heating. This is called eutectic reaction. It is a material science. This is called as a eutectic reaction. Upon cooling, a liquid phase is transformed into 2 solid phases at temperature T. The reverse is asking. That means 2 solid phases upon heating is giving to a liquid phase. Just a reverse of that. That is called as a eutectic reaction. A liquid phase upon cooling, 2 solid phases alpha at a temperature T. Opposite means 2 solid phases upon heating, it will give the a liquid phase, that is called as a eutectic reaction. A material science question. If the specific gravity, again fluid mechanics, specific gravity of the fluid is known, the density of the fluid, density of the fluid will be equal to specific gravity of the fluid into density of the standard fluid, that is water. Answer will be B. Straight question, very simplest question, something like 11th class kind of a question. Such kind of a questions you will not expect in the gate. You will never expect this kind of a question in gate, never. Only this easiness you see only in the ESE paper, because they would ask only peripherally, because calculator is not allowed here. In all the problem, in the prelims, no calculator allowed. Consider the convective heat transfer. Yes, this is a very good question. Following the regard is a heat transfer question, which will influenced by viscosity. H is a function of V, D, rho, mu, Cp, K in forced convection. In forced convection heat transfer, H is a function of influenced by viscosity. Viscosity is there. Influenced by flow velocity, it is also there. Influenced by surface geometry, it is also there. In forced convection. But actually if it is a free convection, actual question is somewhat ambiguous. Because when I said convective heat transfer, it may be forced convection, it may be a free convection or a natural convection. In natural convection, no velocity, here in natural convection. So there is somewhat ambiguous question, because he didn't mention it is a forced convection or natural convection. But no problem, because IAS questions are always like that, only peripherally they will check. So answer will be 1, 2, 3. D is the answer. All three will be there. Velocity, dimension, dimension of body, characteristic dimension of body, mu is the viscosity, all will influence the H value. What is that H called? Forced convection heat transfer coefficient, convection heat transfer coefficient H, or film heat transfer coefficient in forced convection. We will consider it as a forced only. If it is a free convection, there will not be velocity. Dimension will be there, viscosity will be there. Rather, it will be buoyancy forces will dominate there, density changes and temperature difference, acceleration due to gravity. So, different parameters will influence H if it is a free convection, because in the free convection heat transfer, what are the predominant forces? Buoyancy forces, which will try to lift the fluid upwards or sink the fluid downwards in the natural convection. It's a question on heat transfer. Good question. Heat is conducted through a material. Yes, this is a good question asked. Heat is conducted through a material with a temperature gradient of, temperature gradient is given. If this is X, minus dt by dx will be 9000 degrees Celsius per meter. Okay. The thermal conductivity of the material is 25 K. If this heat is convected to the surroundings, this is a convection heat transfer, convection to air, maybe surroundings at 30 degrees Celsius with a convection. Whenever there is a convection is given, the convection heat transfer coefficient must be given 345. Forced convection, it should be a forced convection. By seeing the H, I can say that. What is the surface temperature? What is this surface temperature? Ts. Okay. So, the energy balance says that this heat conducted, Q conducted through slab or through solid material should be equal to the Q convected for steady state or at the boundary. At the boundary, Q conducted is equal to Q convected. Rate of conduction heat transfer should be equal to the Q convection. For what do you calculate Q conducted? Fourier law, minus Ka dt by dx should be equal to the HA, temperature of the surface minus temperature of the air surroundings. A gets cancelled. You know everything, K is given, dt by dx is given, the temperature of the air is there, this is the temperature of the air, 30 degrees Celsius. So, substitute there, H is also given 345. You can easily calculate what is the value of the temperature of the surface. It is 682.17. Answer is C. 682.17. C is the answer. The concept is Q conducted at the boundary should be equal to the Q convected. Look at the boundary condition at the surface. Whatever the heat conducted into the boundary should be equal to the heat convected from the boundary to the air. Air is at 30 degrees. What is this law called? Newton's law of convection, Newton's law of cooling. What is the left hand side? It is called as this is known as Fourier law of conduction. Whenever you are talking about conduction, Fourier law must come. Whenever you are talking about convection, Newton's law of cooling will come. A gets cancelled, you get the temperature of this surface as C. Straight question, very simple question. Diesel cycle, heat is supplied, diesel cycle, very simplest questions you will ask in the IES. Such questions you will never see in GATE. Like in such a simple questions. You may see simple question, but such simple questions you cannot see. This is a heat supply, this is a heat rejection. Okay. Heat is supplied at constant pressure. One is right. It is an adiabatic expansion process. These two are adiabatic. Adiabatic compression and adiabatic expansion. Rejection of heat at constant pressure. No, rejection of heat at a constant volume. Look at that cycle. So 3 is wrong. 1 and 2 are correct. A. regarding the air vessels. Where you use the air vessels? In the reciprocating pumps. Actually it is not there. Reciprocating pumps is not there in the gate syllabus. So that is one difference you may see between the gate and ESE. Centrifugal pumps also not there in the gate, but centrifugal pumps analysis and turbo machine, like a hydraulic turbine, reaction turbine are similar because velocity triangles must be drawn. So centrifugal pumps, we can say somewhat this portion to some extent it is there in gate, but reciprocating pumps, which is also called as a positive displacement type of pump. A reciprocating pump where you have the suction pipe and the delivery pipe, they use the air vessels. They use the air vessels there, no? Water will go inside. They use the air vessels here. They use here one, and here also they use one more on the delivery pipe also. So power expended in the pump will reduce, correct. Frictional losses will reduce. 1 and 2 are correct. A is the correct. Third one is not wrong. For a given speed, there will be increase in the cavitation susceptibility. In fact, cavitation will reduce due to air vessel. This is called as a air vessel. A compressed air will be there. The water level keeps going up and down. The water level will be going up and down. So water keeps getting discharged, entering here, goes into the pump like this. So air vessels, this is a question on air vessels. 3 is a wrong statement. 1 and 2 are correct. Power reduction will reduce because of the air vessels. Power required for the pumping will reduce, and frictional losses in the suction pipe also will get reduced. Regarding the reciprocating pumps, the ratio of theoretical discharge to actual discharge is known as coefficient of discharge. Wrong. Difference between theoretical discharge and actual discharge is slip. Correct. Second is correct. In a double acting pump, both sides of the piston will be displacing. In the reciprocating pump, both sides, there is one system like double acting pump. This is a double acting. Water will be same when the piston is here, when the piston is displacing here, moving this side, water gets sucked here. When the piston gets displaced here, so it is a both sides will be displacing, double acting. Both sides of the piston will have the water going and getting discharged. So 2 is correct, 3 is correct, C is the answer. First one is wrong. This is a question on centrifugal pump. Discharge, specific speed is given, running at a speed of how many pumps are connected. The specific speed formula, Ns for the centrifugal pump. It is a question on centrifugal pump. N root Q by H to the power of 3 by 4. How many pumps connected in series? Pumps are connected in series. Like this, no? Series means the discharge of one pump will be the suction of the another pump. Q is same, but the head will be different, right? Okay, total head will be sum of the individual heads. The discharge of the one pump will be the discharge of second pump. First I have to calculate how many pumps are required there. First I calculate the specific speed. 35 is equal to 1500 into discharge is 0.4, h to the power of 3 by 4. I calculate the h, it will be approximately 80 meters. So how many total this number of pumps will be? Number of pumps will be 240 by 80. 3 pumps. 3 pumps are required. This is the formula for the specific speed of centrifugal pump. N root Q by H to the power of 3 by 4. Water will get sucked up, and again the same discharge will go here, and again one more pump. 3 pumps will be there. But Q is same throughout. Pumps in series means discharge is same. Total head will be the sum of the individual heads. 3 pumps are required. First I calculated by using the specific speed formula, I calculated the H is the head developed by each pump. When the pumps are connected in series, discharge is same throughout, same Q, but total head developed will be sum of the individual heads. Head means the difference between the length of the suction pipe and the length of the delivery pipe. That for each pump, the sum of the lengths of suction pipe and delivery pipe is called as the total head developed by each pump. So the total head to be developed will be 240. Each head, each pump is developing a head of 80 meters. Number of pumps required will be 3. This is the formula for the specific speed of the centrifugal pump. A centrifugal pump as an impeller. It is a question of the vane tips. It is a question on the velocity triangles. It is a radial discharge. Usually, most commonly used pumps are backward curved vanes. This is a backward curved vanes. It is a radial discharge is given. This is a velocity triangle. This is V2, this is VR2, this is U2, blade tip speed at the exit. Therefore, VW2 will be equal to the V2. What is VW2? Component of V2 parallel to U. That will be VW2 will become U2, component of it. So, manometric efficiency formula will be actual general formula will be GHM by manometric head divided by VW2 U2, impeller work. But here VW2 V2 will be it become U2 square. How much is the manometric efficiency here? Point manometric efficiency is 0.82. First calculate the U2 there. U2 will be pi d2 into n by 60. This U2 we got it as the pi into 0.3 into 1450 by 60. It will be 22.765. Tip velocity, tangential. What is U2? Tangential velocity of impeller tip, impeller tip. Once you get the U2, substitute there, you will get the HM there. HM will be equal to manometric efficiency into U2 square by G. G is 9.81. This HM I got the answer as 43.38. This is called manometric head. Head developed by the pump. Manometric head is the head against which the centrifugal pump is working. This is the impeller. This is the backward curved vane impeller. This is the velocity triangle, because he has given that water leaves there is one condition given. The vane tips are radial. That is the main thing. Vane tips are radial. Means VR2 should be perpendicular to the U2. Exit velocity triangle is right angle. Exit velocity triangle is right angle. How do you know it is a right angle? Because he has given one condition, that vane tips are radial at the outlet. Triangle is right angled at outlet. That is why VW2 is equal to V2. That is VR2 is perpendicular to the VR2. This is VR2 is perpendicular to the U2, because the radial vane tips are radial at the outlet. This is the clue in the problem. Vane tips are radial at the outlet. So answer is D. D is answer. The speed ratio, this is the question is, first one, the theory part, this is one is correct. Flow ratio, for low to medium, it will be 9 to 12. Third is wrong, because since it is 9 to 12. speed ratio, this is a formula, speed ratio is defined as U by root 2 GH. Flow ratio will be Vf by root 2 GH. This is the speed ratio and this is the flow ratio. 1, 2 correct. Answer is A. All the questions, centrifugal pumps, he has asked about 3 questions. There are 2 to 3 questions. Reciprocating pumps, he has asked 2 questions. So this overall the turbo machinery part is asking a good number here. In fact, Kaplan turbine is asked 1 question. Turbo machinery asked very good number of questions in ES. In GATE they may ask 1 question. In GATE 2025 has asked 1 question on the Pelton wheel. GATE 2025, this year GATE has asked 1 question on the Pelton wheel. Usually 1 question may come on the turbo machinery in the GATE. The leakage of air in the condenser is a steam power plant. Power plant questions are many in the ESE. Leakage of air in the condenser results in decrease in back pressure in the prime mover. Wrong, it is an increase. See, when the air, if you look at the Rankine cycle, you should get the very good vacuum. If your vacuum gets disturbed, your condenser pressure will increase. Because of the high vacuums inside the condenser, atmospheric air may leak, because of which this condenser pressure or the back pressure will increase. One is wrong statement. The leaked air in the condenser lowers the partial pressure of steam. Yes, the total pressure in the condenser is equal to the partial pressure of the steam plus partial pressure of the air. The total pressure will increase. This is increasing, means this will get reduced. Second statement is correct. The air has got a poor thermal conductivity. Therefore, the convection heat transfer coefficient from the steam to the cooling water will get reduced. Air has got a low thermal conductivity. One is wrong. In fact, because of the air leakage into the condenser, the back pressure will increase. You should prevent any air leakage into the condenser. If at all any air leakage is there into the steam condenser, we have to extract that. By using the air extraction pumps, Edward air extraction pumps. We have to remove that non-condensable gases like air in the condenser. If it is there, what will happen? If there is no proper heat transfer between the steam and the cooling water, because in any condenser, what do you have inside the pipes? You have the cooling water. Outside the pipe you have what? Steam. Steam condenser is a heat exchanger, right? You have a steam. So there is a heat transfer happening here. There is a heat transfer happening. Because of the presence of air here, if the air is there, this will act as a barrier. It will prevent the heat transfer between the steam and the cooling water. As a result, if there is no proper heat transfer, steam will not condense. If the steam will not condense, what will happen? There is no proper low pressure is maintained. You should always maintain this condenser pressure as low as possible. If the steam is not condensing, this low pressure will slowly increasing. As a result, your turbine work output will get reduced, and thereby your overall efficiency also gets reduced. So we have to see that any air is leaking into the condenser, we have to immediately take it out by using the Edward air extraction pumps. Okay, air extraction in the condenser, as far as possible, you should maintain a good vacuum. Usually you will get 65 centimeters of mercury vacuum. You will get usually in all the steam power plants running on the Rankine cycle. This is a Rankine cycle. This is the Rankine vapor power cycle. So if the air is leaking into the condenser, slowly the pressure inside the condenser keep increasing. As a result, your turbine work will get reduced. So you should prevent the air leakage. If at all any air leakage is there, you have to take out that air immediately by using the Edward air extraction pumps. Okay, you should maintain good vacuum. I would like to say a simple sentence. A good vacuum in the condenser is required to get the overall plant efficiency of a steam power plant running on Rankine vapor power cycle. Okay, So 2 and 3 is correct. Very important point. Steam condensers are very important in heat transfer point of view in the GATE syllabus, and in the power plant point of view in the GATE syllabus, and also the power plant point of view in the ESE syllabus. Power plant is a very important subject in both GATE and ESE. Generally you will expect 4 marks in the power plant in the GATE. Here they get very good number of questions. Steam power plant, gas turbine power plant, and also hydroelectric plants. In the reaction turbine, it is also a power plant, steam power plant. Moving blades are of the same type, but in the reverse in the direction. Work done per pair, work done has been given. Work done per kg is 7 Newton meter. If the delta H, enthalpy drop per pair will be 10.04 kilojoule per kg. This is the enthalpy drop. Enthalpy drop per stage. Per kg in stage. One stage means what? What do you mean by one stage of the steam turbine? A row of fixed blades followed by a row of moving blades is called as one stage. In any steam turbine, one stage of the turbine means a row of fixed blades followed by a row of moving blades is called as a one stage. One row of fixed blades followed by a row of moving blades is called one stage. He has asked the efficiency of the stage. Work done per kg divided by enthalpy drop of steam per kg. What is 70,600? That is Newton meter, but this is in kilojoules. 75.7%. 0.757. Answer is C. This is called as the efficiency stage. Like that, so many stages will be there. The main thing of the reaction turbine will be fixed blades and moving blades are of the same shape, provided the degree of reaction, like Parsons steam turbine. In the Parsons steam turbine, the degree of reaction is 0.5. For such Parsons impulse reaction steam turbine, fixed blades and moving blades are of the same shape but arranged in the reverse direction. The rate of heat received by 1 kg of water under working conditions to that received by 1 kg of evaporated from and at 100 degrees Celsius is called factor of evaporation. Answer is A. It is a comparison this equivalent evaporation rate. Actually, it is also called as equivalent evaporation rate. Equivalent evaporation rate, that is also called, same meaning, factor of evaporation or equivalent evaporation rate. For comparison of boilers, it is taken as a one important parameter when you are comparing 2 or 3 boilers. Actually, in the boiler, how much heat is received? How much heat is received from the inlet to the exit? Actually, divided by if the same water enters the boiler at 100 degrees Celsius as a saturated liquid, how much latent heat is required? Latent heat of vaporization, at okay. But in fact, this equivalent evaporation rate, it is also called as mass flow rate of the steam generated. If this is H1 minus H2 divided by latent heat at 100 degrees Celsius. This is the definition for the equivalent evaporation rate or factor of evaporation. This is the formula he is asking. This is the parameter meant for comparing the various boilers, because different boilers will have the different boiler pressures, different superheat temperatures. So, different inlet conditions you may have. For comparison of the boilers, this factor, which is called as the equivalent evaporation rate or factor of evaporation, is taken as the comparative parameter. If you are comparing two boilers, this m dot E is taken as the parameter for the comparison. This is also called equivalent evaporation rate or factor of evaporation. Babcock-Wilcox is a water tube boiler, it is not fire tube boiler. Babcock-Wilcox is a high pressure water tube boiler. It may be designed for stationary or marine purposes, locomotive. Even for that, drum connected to a series of front and rear end headers to a short riser tubes. Yes, it is a natural convection. It is a natural convection high pressure water tube boiler. It is a natural convection, not forced convection. It is a natural convection high pressure water tube boiler. Generally, boilers, fuels and combustion, they ask good number in the PPE, but in a gate, they may ask, they may not, mostly they may not ask. Steam generators or boilers. It is there in the gate syllabus, but peripherally. Don't have to go deep. But generally, equivalent evaporation rate, everything, boiler efficiency, they used to ask earlier gate. But nowadays, is not touching the boilers, steam boilers or steam generators. But in IES, it is important. Answer is C. It is a locomotive. Locomotive boiler is a fire tube boiler. Locomotive boiler, it is a fire tube boiler. What do you mean by fire tube boiler? Inside the tubes, we have the flue gases, combustion gases. Inside the tubes, we have the combustion gases. Outside the gases, we have the water. This is called as the locomotive boiler, is a fire tube boiler. There are 4 fire tube boilers. Lancashire, locomotive, Cochrane, Cornish. There are 4 fire tube boilers: Lancashire, locomotive, Cochrane, Cornish. There are 4 fire tube boilers. Rest of all are water tube like Stirling boiler, Babcock-Wilcox boiler, Benson boiler. Water tube boilers only are very prominent in the steam power plants. All the modern day steam power plants, high pressure steam power plants will use water tube boilers. Like Stirling boiler, Benson boiler, all supercritical boilers are usually water tube boilers. Water tube boilers, what will happen? Water tube boilers, what will happen? Inside the tubes you will have the water, outside the tubes you have the flue gases. So here the 1 and 2 are correct. The fire tubes are placed inside the smoke box, wrong. Fire tube are placed in the shell. In the fire tube boilers, these fire tubes are placed in the shell, not in the smoke box. So 1 and 2 are correct. A. Locomotive boiler is a fire tube boiler, whereas Babcock-Wilcox boiler is in the previous one, Babcock-Wilcox boiler is a water tube boiler. High pressure natural convection water tube boiler, Babcock-Wilcox. Very famous boiler it is. Horizontal inclined drum water tube boiler is Babcock-Wilcox. A boiler generates 360 kg of steam per hour. Quality of the heat supplied is calorific value is given. That is, he has asked the boiler efficiency. What is the formula for boiler efficiency? This is a general thermal efficiency of the boiler. It is heat actually utilized in generating steam divided by heat generated by combustion of fuel. Heat generated by combustion of fuel. How much heat is actually utilized in generating the steam? How much steam per hour? 360 kg. Quantity of heat supplied per kg of steam will be 2560.6. Each kg is receiving this much heat. 360 kg are generating. How much fuel are consuming? 60 kg per hour. Each 1 kg of fuel is liberating this much amount of heat. What do you mean by calorific value of the coal? What do you mean by calorific value? It is the amount of heat liberated when 1 kg of the coal undergoes complete combustion. So this will give you the, usually thermal efficiencies of the good maintained boiler may touch up to 90% actually, but here it is only 52.53. A well maintained boiler may have 80 to 90%. How much heat is actually given to the water in generating the steam, how much heat you are getting by burning the fuel. This is a calorific value. What do you mean by calorific value? 1 kg of the coal, if it burns, completely burns, how much heat you will get out of the burning of the coal. That is called a calorific value. Understand? How much heat is actually transferred to the water in generating the steam, numerator. Denominator is how much heat you are getting by burning the fuel. A coal grading, it is coal grading, all the three size of, this is a coal grading there, 5 into 10 is size of the coal, heating value of the coal, and this is A for the ash content. Okay. Answer is D. Coal grading, how much, S may be the sulfur, S may be the sulfur content in the coal. So each letter will correspond, A for the ash content, S for the sulfur, this is the size of the coal grain. So that is the, how do you grade the coal, on what parameter? Generally a coal having a least sulfur is desirable, because sulfur it will give the sulfur dioxide, and sulfur dioxide and water vapor will give the H2SO4, sulfuric acid, which is of highly corrosive in nature. Sulfuric acid is highly corrosive in nature, and also it will cause the acid rains, highly pollutant, highly toxic sulfur dioxide. So coal having very low sulfur is desirable from the pollution point of view. See, there is also boiler there, advantage of regenerative cycle, yes. Regenerate, what do you mean by regenerate? Very important in gate point of view. In gate point of view, regeneration is very important, regeneration in the Rankine cycle, because many times in the gate the question has come, so many times. In the regeneration, in the regenerative cycle, some of the steam will be extracted and it will be used to heat the water. This is called bleeding of steam. So many times that such questions on regenerative Rankine is gate, many times it is asked. The heating process in the boiler tends to become reversible, yes. Because of this regeneration, the irreversibilities got reduced. One is correct. Heat rate is increased. What do you mean by heat rate? Amount of the heat required to produce 1 kg of the steam actually. So here the heat rate is reduced because of the regeneration. Thermal efficiency of the Rankine cycle increase due to regeneration. Please remember, why do we do this regeneration? To improve the thermal efficiency. The main objective, the main focus of doing the regeneration in any thermodynamic cycle is to increase the thermal efficiency. Remember, wherever you talk about this word regeneration, its prime objective will be to increase the thermal efficiency. Here also thermal efficiency of the Rankine cycle is increased, therefore heat rate got reduced. 2 is wrong. A small size condenser is required. Yes, that means this is the boiler pressure. This is the condenser pressure. Why small size? Because you are already trapping some mkg of steam. You are already trapping. So only that if you think that 1 kg is entering, mkg is already trapped. You will have only 1 minus mkg of steam. That means a lesser size of the condenser may be required. 3 is correct. 1 and 3 correct, that is B. Answer is B. The main purpose of regeneration is to improve the efficiency, thereby to reduce the fuel consumption rate, cost of production, cost of the power production will get reduced because you are consuming lesser fuel, because efficiency got increased. It is also a steam turbine. See how many questions he has asked in the power plants. Boiler around 3 to 4 questions, power plant engineering in particular ESE will ask about more than 12 questions out of 150. More than 12 questions, sometimes 13 questions they may be asked. Putting gas turbine, steam power plant and hydroelectric power plant put together, they may go touch up to 15 questions. Whereas in gate, around 5 marks, power plant 4 to 5 marks. I mean to say refrigerator. In the power plant and RAC and IC engines all put together 5 marks in gate. That is refrigeration, air conditioning 1 question, autos, IC engines maybe 1 question, and 2 questions from the steam power plant and Rankine cycle and gas turbine power plants in gate. You may ask around 5 marks higher side. But see how many questions he is asking here. In case of a steam turbine Rankine cycle, work done per total heat supplied, work done, thermal efficiency will be very simple question, very simple, work done per kg divided by heat supplied per kg. Such simple questions you will never get in gate. 1080 you are getting, how much heat you are supplying? 3076.1. Direct straight questions, work done per kg by heat supplied per kg, you will get 35.1%. Straight, very straight, simple questions. No thinking required, very simple basic definitions if you know also you can put the answer. In the reheating, you see Rankine cycle itself is asking so many questions. Reheater may be heated by a coil carrying the high pressure superheated steam. Reheater may be heated by a coil carrying the high pressure superheated steam. There is a reheater may be heated by a coil carrying the high pressure superheated steam. In the Rankine cycle, it looks like this. Reheat Rankine cycle looks like this. After certain expansion in the turbine, again the steam will be reheated in a coil, by supplying to it. This is called reheating at some intermediate pressure. Generally it is done at 25% of the boiler pressure. Totally 3 pressures will be there. This is the reheating. No, this process is called as the reheating. Generally reheating is done to reduce the moisture content during the later stages of expansion to prevent erosion. At optimum pressure, at 25% of the boiler pressure, this reheating should be done. Okay. 1 is correct, 2 is also correct. A large proportion of the heat supplied in the process will be thrown to the waste in the condenser. Yes, good, because in the condenser your large portion of the heat supplied in the reheater is thrown in the condenser there. This heat, right? This extra heat you are throwing into the condenser. 1, 2, 3 are correct. What is the main purpose of the reheating? This is the coil. What is the main purpose of the reheating? To reduce the corrosion and erosion, to reduce the erosion of turbine blades. This is very important. Main purpose of reheating in Rankine cycle. This is a very important point in gate also. He is to reduce moisture content of steam during later stages of expansion, thus avoid erosion of turbine blades. Avoid of blade erosion. Erosion means if the moisture content is more, here see there may be a chances of erosion at this point. You are taking the steam to reheating and then expanding, there is a chances of erosion here is quite lesser because moisture content is lesser, because this point is closer to the dry saturated vapor line. This is the dry saturated vapor line. This point is closer to the dry saturated vapor line. Therefore, moisture content is lesser. Water vapor, liquid particles in that steam, the liquid particles are lesser here as compared to this point. So, the erosion of the turbine blades gets reduced. You should maintain always dryness fraction x greater than or equal to 0.9. X is called dryness fraction. During any part of expansion in the turbine, your dryness fraction should be more than 0.809 or above 0.9. Maximum 12%, 10% moisture you can permit. If the moisture content is more than 10% or 12%, there is a danger of the turbine blade erosion. That erosion you can avoid completely by providing this reheating. That is the main advantage of reheating. Of course, because of reheating you may get little increment in efficiency, and you may get more power, you will get higher power output, because you have got two turbines, you got high pressure turbine and low pressure turbine. So this reheating and regeneration are two important modifications in the Rankine cycle. Questions are very common in the gate also on these two. Critical temperature, 1 is correct, 3 is correct, CH4 is wrong, 1 and 3 are correct. He has asked the critical temperature. Critical temperature is the temperature where the latent heat of vaporization is 0. This is the critical point. Critical temperature, the refrigerant must have the high critical temperature. The desirable property of the refrigerant is that, the most desirable property of refrigerant is that it should have highest critical temperature possible, should have high critical temperature. Then it is said to be a good refrigerant. Regarding VCR cycle, normally in the practical cycle, the temperature of the liquid refrigerant leaving the condenser is lower than the saturation temperature. Yes, they provide usually the subcooling. Generally in the VCR cycle, usually the subcooling is provided. What for this subcooling is provided? This subcooling is provided commonly. In a simple dry saturated VCR cycle, it may go like this. But generally, we always provide the subcooling. Why this when you provide the subcooling, you will get RE extra. You get refrigeration effect extra you get. This is RE extra. Refrigeration effect extra you get because of this subcooling. So thereby increasing the coefficient of performance. Your COP also will be increased. See, in a simple dry saturated VCR cycle, directly without subcooling, you will take the refrigerant into the expansion valve. When you provide the subcooling like this, you will come like this. This is the condenser pressure, this is the evaporator pressure. This is called a typical VCR cycle with subcooling. When you provide the subcooling, you are likely to get more refrigeration extra. You are getting extra, RE extra, refrigeration effect extra. Thereby, your COP will definitely coefficient of performance will increase. Subcooling ensures that no vapor enters the expansion valve, and furthermore it increases the refrigeration effect. Yes, correct. The refrigerant is also subcooled before leaving the evaporator. No, before this is evaporator. There is no question of subcooling here. So questions are 1 and 2 correct. Answer will be A. Subcooling after the condenser you do, not at the end of the evaporator. At the end of the evaporator you may do the superheating of the refrigerant vapor. So this portion is called subcooling. Subcooling means after condensing the refrigerant vapor at constant pressure, you are decreasing the temperature further below the saturation temperature, around 5 to 6 degrees subcooling you may provide. Usually not more than 6 degrees Celsius. Thereby your RE will be increasing, coefficient of performance will be increasing, you will get more tonnage of the refrigeration plant. There are many advantages. This question is on the subcooling in the VCR cycle. Addition of this is all these questions regarding the ICE. Now we are coming to the internal combustion engines, ESE engines, petrol engines. Addition of hydrocarbon emissions to the exhaust during scavenging process in a two-stroke. The main drawback of the two-stroke cycle engines is they have the lower thermal efficiency as compared to the four-stroke engines. Why? During the scavenging operation in the two-stroke cycle engines, we have the ports. You don't have the valves. You don't have the valves, right? You have the ports. You have the one transfer port, exhaust port, and inlet port. 3 ports will be there. So because of this is a piston. This is a piston, right? We have the lubricant here, crankcase and all that. So, there is every possibility that the exhaust gases, along with the exhaust, some freshly from fresh charge, some fresh charge may escape along with the exhaust gases to the exhaust, at some unburnt fuel, air fuel mixture may escape along with exhaust gases, So that thereby your thermal efficiency will be lower. Air fuel mixture is used to push the exhaust residual, yes, correct, 1, 2. Lubricating oil is fully combustible as readily, because of which there is a more pollution caused because of the 2-stroke engines as compared to the 4-stroke. Is connected to the answer is D. Hydrocarbon emissions will be there because unburnt air fuel mixture may escape along with the exhaust gases, and as a result you will have the lubricating oil also. This is called this lubricating oil also, So that also may undergoes, there will be a scoop. This lubricating oil may go into the combustion chamber, it may undergo combustion and may cause some more pollution there. Okay, lubricating oils also may undergo combustion, particularly in the 2-stroke engines. This is 2-stroke petrol engines. This is a problem, like our Yamaha bike is a 2-stroke petrol engine, RX Yamaha 100. It will give you more power as compared to the 4-stroke, because in each revolution of the crankshaft you get 1 power stroke. In each revolution of the crankshaft, you get 1 power stroke. So for the same speed in 4-stroke and 2-stroke, you get double the power theoretically, but you get poor thermal efficiency, lesser mileage. That is the drawbacks in the 2-stroke engines as compared to the 4-stroke. This is regarding the combustion and the ignition delay. This is regarding the CA engine, diesel engine. Ignition delay is if this is a motoring curve, what is ignition delay? Ignition delay will be from the moment you start injection, to the, if this is a combustion curve, to the moment you start injection, at the moment you start energy release, ignition. This delay, what is that ignition delay means? From the start of injection, from the start of fuel injection to the start of combustion, to the start of ignition. Start of combustion or start of ignition or combustion also. That gap is called as the delay period. If the delay period is long, more chances of detonation in the CA engines. If delay period is long, more chances of detonation in CA engines. More chances of detonation in CA engines or diesel engines. CA engines or diesel engines both mean the same. At higher engine speeds, ignition delay is decreased. Actually, that is a wrong statement. That is a wrong statement there. Yeah, correct statement. Sorry. At higher engine speeds, ignition delay is decreased. Yes, because of the more turbulence. The reason is more turbulence. Correct. Reason, more turbulence. At higher speeds, more turbulence, more mixing. So the fuel takes lesser time to begin the ignition. What is the delay period? Delay period is the time lag between the moment you start injection to the moment where the ignition start of combustion. Combustion has already started. From the moment you start injection to the moment you start ignition of the fuel or combustion is initiating, that time lag is called as the delay period. Delay period consists of 2 periods. One is physical mixing and chemical interaction. Physical mixing means small air molecules and diesel molecules must mix up. Chemical interaction means they must undergo certain chemical reactions and then finally begin to release the heat energy. So from the moment of the injection, you start injecting by using the fuel injector, to the moment where the energy starts releasing, heat energy, chemical energy got converted into the heat energy and heat energy got releasing, that time lag is called as the delay period. This time lag is called as the delay period. If injection is too early, ignition delay period time will decrease, because by advancing the fuel injection the delay period will decrease. Second is correct. If the C10 number is low, ignition delay will be too long. Yes, C10 number means anti-knocking characteristics. C10 number is anti-knock characteristic number, anti-knock characteristic number in CA engines. If the delay period is if the C10 number is low, means detonation is becoming more. That means delay period is long, more chances of detonation in CA engines. So all three statements are correct. D is the answer. Please note that to avoid detonation in the combustion ignition engines or diesel engines, the delay period or ignition delay period must be as low as possible, as small as possible. If the C10 number is low, means detonation chances are higher, which means that ignition delay period is long. To avoid detonation, you think of like this, to avoid detonation, the moment you start the injecting the diesel fuel, first molecules of the diesel fuel after going into the combustion chamber, they must begin the combustion at the earliest. The first molecules of the diesel fuel after striking the air, they must begin the combustion as soon as possible. Then the delay period will be lesser, then the detonation chances are lesser. That means the combustion phenomenon, detonation in a CA engine goes like this. If the delay period is long, there is a more amount of the diesel get accumulated in the combustion chamber. By the time the first molecules give the flame, as a result all the diesel molecules accumulated will undergo instantaneous combustion, thereby giving the very sudden pressure rise and the cyclic fluctuations of the gaseous products. Pressure will rise, pressure will fall, again rise. That means, very simple point I would like to tell, the delay period must be small to avoid the detonation in CA engines. That means the first molecules whatever got injected into the combustion chamber, they should begin the combustion as early as possible. Thereby delay period is lesser. All the three statements are correct. This is also CA engines. In atomization process, fuel drops break into very small droplets. Correct? This is correct. In vaporization process, the small droplets of liquid fuel evaporate into vapor. Actually, in the diesel engine, there is a fuel injector. That fuel injector atomizes the small droplets, small tiny droplets, and those droplets must vaporize into the droplets, small droplets evaporate into the vapor, and those vapor molecules must mix with the air, undergo the chemical combination. The smaller the size of the fuel drop emitted by the injector, less efficient will be the atomization process. No, smaller the fuel drop, more efficient will be the atomization process, right? Small means atomization process means what? The fuel inject must inject the diesel fuel in the smallest drop size diesel fuel. So at that smaller the fuel size, the less efficient. 3 is wrong, 1 and 2 are correct. A is the answer. Actually there are two things. The fuel injector used in the diesel engine, CA engine, must be able to atomize the diesel fuel. That means break up the liquid droplet into small tiny particles, and those diesel molecules after touching the air, they should undergo vaporization, and they should undergo physical mixing and then chemical interaction and start releasing the heat energy. 1 and 2 are correct. This fuel injector is connected to the fuel injection pump, which is also called as the Bosch pump. Only in the CA engine or diesel engine we have the Bosch pump, which increases the pressure of the diesel. So the pressure of the diesel also will decide the atomization process, will decide how well the atomization process will be. Atomization means the liquid droplets must get divided into tiny atomized particles, and then they will evaporate. See, in vaporization process, the small droplets will evaporate into the vapor, and then they undergo the chemical reaction with the air molecules. This is regarding the carburation. This question is regarding the carburetor in SI engines. At very low engine speeds, the throttle will be almost closed. In the carburetor, there is a venturi, there is a venturi, this is a fuel jet in the carburetor. There is a fuel jet. There will be a throttle valve. The throttle will be almost closed, resulting in a high vacuum in the intake manifold. They will go to the intake manifold. Correct. When quick deceleration is desired, the throttle is called at a very large vacuum is created in the. When a quick deceleration is required, this is the throttle valve. When the throttle valve is almost closed, throttle is called throttle. When this throttle is almost closed, a very high vacuum is created. When a cold engine is started, an overrich supply of the must be supplied. Yes, correct. When that air fuel ratio is required here will be around 9:1. The air fuel ratio required will be around 9:1. This is a air fuel ratio in cold starting of SI engine. So all the three statements are correct. This is called cold starting. That is why you will use the choke. Choke is during the cold starting engine, you will apply the choke there, you will pull the choke so that to enrich the mixture. Always actually in the carburation process, cold starting, idling and accelerating and economy range. There will be 4 air fuel ratios you have to remember. Cold starting, idling means what? Running the engine under no load conditions. That is also requires rich mixture. And again economy mixture will be there 16:1 and peak power operation will be there, it is around 12.5:1. So there are 4 different air fuel ratios you need to remember. The third question is regarding the cold starting. It is for cold starting you require by using the choke valve you may be enriching the fuel. Okay. All the 3 statements are correct. At very low engine speeds, throttle valve will be almost closed, resulting in a high vacuum in the intake manifold. When it is almost closed, you get a intake manifold, you get the high vacuum. This is a throttle valve, this is a venturi. This is a venturi in the simple carburetor. This is a fuel jet. Fuel jet. This air keeps coming from the atmosphere into this. Okay, a simple carburetor principle. This will be molecular weight of the simple molecular weights is asking 1 and 2 only correct. For the carbon monoxide it will be CO, right? CO will be 12 plus 16, 28. Simple chemistry is asking. This is air will be 29. Argon will be 39.5. 1 and 2 correct. Nobody will ask the chemical molecular weights in the gate. In ES only he is asking. 1 and 2 correct. Axial flow ratio of the actual enthalpy change in the rotor, actual change of enthalpy is known as degree of reaction. A is the answer. Degree of reaction will be the enthalpy change in the rotor divided by enthalpy change in the rotor plus enthalpy change in the stator. That is called as a stage. This is called degree of reaction. Answer is A. A centrifugal compressor is like a pump head producing device. 1 is correct. Is suitable for low specific speed and higher pressure ratio. 2 is also correct. Centrifugal compressor is a lesser efficient than the axial flow type. 3 is also correct. Axial flow compressors are more efficient. But generally centrifugal compressors are required for the high pressure ratios and moderate discharges and lesser efficient than the axial flow type, but very rugged. Centrifugal compressors are very rugged structures, therefore they are insensitive to the pollution, air pollution. Whereas axial flow compressors are more efficient, but they are very sensitive to the air pollution. So their efficiency may drastically reduce if the air quality is not proper. And axial flow compressors require more number of stages for a pressure ratio. You require 6 to 7 stages. per stage centrifugal compressor can deliver more pressure ratios and moderate air volume flow rates. Axial flow compressors, because the flow is parallel to the axis of rotation, they can handle very high volume flow rates and high discharges. It is like a pump. Only difference between centrifugal pump and compressor is a pump handles the water, whereas compressor handles the air. All the three statements are correct. D. Centrifugal, all the modern day aircrafts, and jet engines will use the multi-stage axial flow compressors, maybe 10 to 12 stages also, depending upon the pressure ratio. The pressure ratio per stage in the centrifugal compressor will be much more than that in the axial flow compressor. Axial flow compressors will have more efficiency than the centrifugal compressors. Centrifugal compressors are very rugged in structure and less sensitive to the air pollution. Their efficiency will not decrease even if the air gets polluted, but whereas for the axial flow compressors, the efficiency may decrease drastically if the air gets contaminated or if there is any coating. If there is any thin coating or the pollution, because of the pollution, any thin coating is there on the blades, axial flow compressor blades, their efficiency may get reduced. And turbojet engines, it is suitable for long distance. 1 is correct. Reheat can be employed. 3, all the 3 statements are correct. What is a turbojet engine? Turbojet engine will be there is a compressor, there is a diffuser, there is a compressor, there is a combustion chamber, there is a gas turbine. Gas turbine purpose is only to drive the compressor. After that you have the nozzle and that high velocity jet of gases leave, providing the thrust, forward thrust. Diffuser, compressor, combustion chamber, turbine. Work of turbine will be equal to the work of compressor, and this is the main thing where the expansion of the gases would happen, resulting in high velocity jet of gases. So this is called turbojet engine. Generally 5 jet propulsion systems will have turbojet, turboprop, ramjet, pulse jet and rocket. A pulse jet is a mass pulse produced in a short time due to its simple construction in low cost, correct. Suitable for one-time military operation, that is also correct. It has turbine, no, 3 is wrong. Pulse jet has no turbine, no compressor. Pulse jet and ramjet, they don't have any turbine and compressor. A pulse jet engine will have the a valve will be keeps getting closed and open there. Pulse valve, there is an entry of the air, there is a fuel, so that valve gets closed and open. There will be a pulse. In each pulse, valve gets open, air comes and undergoes combustion. You will have the nozzle. It's okay. Ramjet engine does not have a compressor and turbine. 1 correct. Ideal for hypersonic aircraft. Only when the speed of the aircraft is very high, ramjet will be used. Test shows that subsonic flow system is right choice. No, 3 is wrong. 1 and 2 are correct. A ramjet is very simple. Ramjet will be, there is a diffuser, a combustion chamber, no turbine, nothing, and again you have the nozzle. But it should be given initial velocity. A ramjet must be given a high velocity first by some engine. After that it is self-propelling. Combustion chamber, there is a fuel will be added, and diffuser, combustion chamber, nozzle, and this is called ramjet. No turbine, no compressor. Only suitable for hypersonic. Hypersonic means what? When the Mach number is greater than 3, it is called hypersonic. M is called Mach number. In a Kaplan turbine, what is the specific speed? Specific speed is straight formula for the turbine, n root P by h to the power of 5 by 4. Only thing is power, you have to keep it in kilowatts. Head is in meters. And everything is there, and you will get 410. Generally, generally Kaplan turbine specific speed highest, NS of Kaplan is highest among all the turbine. For 450 to 1000 it may touch. Lowest in Pelton wheel. Specific speed of Kaplan, Pelton wheel is lowest, Kaplan is highest. Pelton wheel is lowest around 15 to 20 or around 10 to 20 Pelton wheel specific speed. Increasing initial in the steam turbine. If you increase the boiler pressure, what will happen is asked. See, again good number came into the Rankine cycle. So many questions from the Rankine cycle. Increase in initial steam pressure gives the higher saturation temperature below the critical value. Yes, as you increase this, the saturation temperature also will increase. Higher the saturation pressure, higher the saturation pressure, higher the saturation temperature. One is correct. The gains in thermal efficiency obtained by the large increase in the initial steam pressure in the higher ranges are of the order of 5% or more. Yes, 2 is also correct. The wet steam in the larger part of the turbine would give lower turbine stages. This is wrong. 1 and 2 are correct. A is the answer. As saturation pressure increases, saturation temperature of the steam also will increase obviously. 1 is correct. As a result of increasing the boiler pressure, you will get the more thermal efficiency, no doubt. But danger is there is a turbine blade erosion may happen because of this higher boiler pressures. But that can be avoided by putting the reheating. When you are going for higher boiler pressures to gain more efficiency, there is another danger. After expansion, supposing if you are going the expansion like this, there is a lower dryness fraction values may get and that may cause the turbine blade erosion, but there is a remedy for that. Provide reheating. That is why whenever you are looking for higher boiler pressures, you obviously provide the reheating. Answer is A. Again steam and gas turbine. Gas turbine power plants operate at lower inlet gas temperatures and higher pressures. Wrong. Gas turbine power plants will operate at higher temperatures. Gas turbine power plants, the peak temperatures in the gas turbine power plants will be around 1300 Kelvin. This is the Breton cycle. Breton cycle for gas turbine plant. Whereas the steam power plant which is running on the Rankine cycle, the highest temperatures may be around 500 to 550 degrees Celsius, whereas that is 1300 Kelvin. It is the gas turbine. This is the steam turbine. A is wrong. Gas turbine power plants operate at the same inlet gas temperature. Wrong. This is higher. Gas turbine operate at a higher inlet gas temperatures and lower pressures. Yes. Here the pressures may be around 10 bar or 15 bar. Here the pressure, boiler pressures will be minimum to minimum 150 to 200 bar, minimum to 150 bar, 100 to 150 bar. So here it is only 10 bar. So answer is C, higher inlet and lower pressure. C is the correct answer. It is subjected to more temperatures, but pressures are lesser, around 10 bar, 8 bar like that. Here 100 bar, 150 bar, 200 bar, even more than that. The critical pressure of steam itself is 221 bar. There are boilers, there are steam power plants operating more than that. 250 bar also you have the steam power plant. This is Rankine cycle. That is Breton cycle. This is for the gas turbine, this is for the steam turbine. Primary purpose of superheating applied to the primary. To decrease the power plant efficiency. No, to increase, to avoid, so why you provide the superheating in the Rankine? See how many questions he has asked in the Rankine cycle. He has asked more than 15 questions I guess. Why you provide more superheating? To increase the power plant efficiency, to avoid too much wetness. Yes, B is correct. To increase the initial condensation losses. No, to make the steam visible. Answer is only one answer. To avoid, B is the answer. So as you provide more superheat temperatures, your dryness fraction values will be higher. Your dryness fraction values, here the dryness fraction values is more as compared here. As such, as the dryness fraction values are more, wetness is lesser, erosion is lesser. To avoid too much wetness, wetness means lesser dryness fraction values. This point has got more dryness fraction as compared to this. As a result, erosion chances also will be lesser. This is, I prefer this expansion to avoid the turbine blade erosion. When do the turbine blade erosion will happen? If the dryness fraction values falls lesser than 90%. If the dryness fraction values falls lesser than 90%, if the moisture content is more than 10% or the wetness content is more than 10%, there is a more chances of the turbine blade erosion. By providing this more and more superheating, that danger can be avoided. So, but maximum you cannot grow above 550 degrees Celsius. Usually 450 to 500 they stop. Currently in India, we are using around 450 highest temperatures in the steam power plants. In the Rankine cycle, currently we are using around 550. Japanese and all they are using around 700, but in India we are using around 500, 550, not more than that. Right? Yes, again reheating. Erosion and erosion problems, I already said, the main purpose of providing reheating in the Rankine cycle is to avoid the turbine blade erosion. If you go straight, there is a lesser dryness fraction values. If you do after partial expansion, if you do this reheating and again expand, this point will be shifted to here. So as a result, there is a lesser moisture content because this point is closer to the dryness fraction dry saturated vapor line. So at this point, the dryness fraction values are more as compared to this point. So there is a lesser chances of erosion. Is improved, yes, the final dryness fraction is improved. There is decrease in the nozzle, no, there is no connection here, 1 and 2 are correct. A. Erosion, corrosion problems are avoided because you should see that no water droplet, generally as less water droplets are possible. See, as compared to here, the moisture content here is lesser. Moisture content means the condensed liquid water droplets. If they hit the high velocity with the great velocity to the turbine blades, that may cause the erosion. Erosion means turbine blades get damaged. So that can be avoided by providing this reheating in Rankine cycle. A fuel cell, now see how many power plant questions is asked, more than 15 questions have come, gas turbines and steam turbines put together around 10 to 15 questions have come in the out of 150. A fuel cell is you supply the hydrogen, you supply the oxygen, there will be reduction, oxidation, chemical reactions, there will be catalyst, anode, cathode, etc. and finally you will get the electric power. A little bit electric power plus water vapor plus little bit of heat. So a fuel cell you will meant for producing electric power, static power conversion device. Converts not mechanical energy, it is a chemical energy. It is not mechanical, wrong, it is a chemical energy. Is a static power conversion device, yes, correct. The only exhaust if pure hydrogen is a pure oxygen is water vapor, yes, correct. 2 and 3. C is the answer. 2 and 3 are correct. Static power, only exhaust are the, if you supply the hydrogen gas and oxygen, you will get the electric power. Actually people are using this hydrogen as a fuel for generating the power to drive the cars. Hydrogen powered cars people are designing by using this principle. You are generating electric power by supplying hydrogen and oxygen. It is a chemical energy getting converted into the electrical energy, electric power. That is the principle of the fuel cell. Biomass energy. These are all the problems in the renewable sources. You don't have this renewable energy sources. Renewable energy like solar energy, biomass energy, wind energy, tidal energy, fuel cell. These are all come under solar, biomass, wind, tidal energy, fuel cell. All these come under the renewable sources of energy, which is a main important subject in ESE. There are asked more than 10 questions on this, 10 to 12 questions. In GATE it is not there. No renewable energy. This chapter is there only in the ESE. This is regarding the biomass. Biomass means what? You will lot of biomass available in India also. We will we will collect all the wood waste, etc. like wood, and we will densify that by we will prepare pellets, you will be creating briquettes, and from that you will try to get the biodiesel, or you will try to use it as a fuel. Finally you will want to use it as a fuel and produce some producer gas from that. You got the producer gas is one of the important biomass gas. Okay. Pelletization process in which the waste wood is pulverized, dried and forced into an extrusion device. Yes, correct. One is correct. Biomass briquettes. Briquettes are bigger in size than the pelletization. Round 2 is correct. Woody matter. So dried wood gets collected. They dry it. They will powder that. They will prepare pellets and biomass briquettes. Concentrated vegetable oils may be obtained from certain but can be used. This is wrong. Can be used. This is a can be used. So 3 is wrong. Biodiesel is that only. Biodiesel. Biodiesel is getting from particular seeds, and that biodiesel is used in the diesel engines. Vegetable oils. Biodiesel is a vegetable oil. Now you must have seen that green color buses there, diesel engines which are powered with a biodiesels. Because which is a renewable source of energy, thereby that exhaust pollution also may be lesser. They haven't used the biodiesel there. 3 is wrong, 1 and 2 are correct. A. Biomass is India is being an agricultural country. You have a good potential to create a biomass utilization for the as an alternate source of energy instead of depending upon the petrol and diesel. Ethanol you can get. Ethanol is the main one of the C2H5OH is one of the important byproduct which can be used as a IC engines also. Along with the petrol we can use it IC engines. Biodiesel is used in the CI engines. This is the tidal energy. This is the tidal energy. 1 and 2 are correct. In single basin double effect scheme, power is generated on both flood and ebb. Okay, flood side and ebb side, in both sides power can be generated. When the flood is full, you can generate the power. When the ebb is full, you can generate. Linked basin scheme consists of 2 basins, one topped up at high tide. This is also correct, and 3 is wrong. A is the correct answer. This is the tidal energy. Regarding the wind energy, 1 and 3 are correct. Not the Australians. Europeans were the first to use the 2 is wrong. 2 is wrong. Europeans were the first to probably use the windmill around by using the wind energy or generating the electric power. Because the wind energy history, this question is asked. Distillation is distillation is the process to convert the saline water. In the Gulf countries, they do this distillation only. They take the sea water and produce the fresh water. Because they have enough petrodollars. In the Gulf countries, they get the sea water and convert the fresh water. About 20% of these brackish. Brackish means low salinity. Brackish means low salinity. Only 30% of the water in this is fresh. Only 2%. 3 is wrong. Just 1% to 2% of water available on the earth is fresh water. About 20%, 2 is correct. 1 is correct, 2 is correct. A is the correct. Distillation means getting the take the saline water and gets the fresh water. It is a water treatment. Design of a greenhouse depends upon the greenhouse means what? Greenhouse is a structure where you have a glass cover or some plastic cover where you are producing agriculture. You are producing you are growing the trees, plants inside that cover. A greenhouse, this is a plastic or a glass plastic or glass, and you are maintaining a controlled environment. You are maintaining a controlled environment, RH, dBT, drivable temperature, etc., humidity, RH, relative humidity, and then you are growing the plants there. Design of green depends upon the local climatic conditions, or for arid zone are designed to conserve water. Arid zone means there is no water resource, there only greenhouses will be used. In tropical countries, solar installation ambient number quite higher, and therefore winter greenhouse, not winter, this is called as a summer greenhouses, particularly in the locations near to the equator, tropical countries. India is in southern India, like we in Trivandrum in the tropical region, and the ambient temperatures are quite higher, and therefore solar greenhouses are used to maintain low temperatures and insert just sufficient sunlight for photosynthesis. There is a sufficient sunlight for photosynthesis and for the growing of the plants. This is called as the greenhouse. You maintain a proper relative humidity, proper dBT, and pollution free, so that more yield of the agricultural things can be expected. That is called as a greenhouse. Solar refrigeration. All these are regarding the renewable energy sources. Solar refrigeration. In absorption cycle, 1 is correct, 3 is also correct, 2 is wrong. So that the absorbent has low affinity. Absorbent should have more affinity. A VAR system can be run with the solar energy. That is called solar refrigeration system. A VAR system can be run with the solar energy. The absorbent should have more affinity towards the refrigerant. In any vapor absorption refrigeration system, absorbent should have more attraction, more affinity towards the refrigerant. Like water has got more affinity towards the ammonia. Like lithium bromide salt will have more affinity towards the water. So that affinity attraction should be there between the absorbent and the refrigerant. But he has given low affinity. So 2 is wrong, 1 and 3 are correct. Refrigerant can be bound by a liquid or solid solvent known as absorbent to release heat during the absorption. In any vapor absorption refrigeration system, a refrigerant will be well absorbed by the absorbent. During that absorption, there will be some heat released, and that may be taken by some cooling water. This is a simple example of VAR system run with solar energy. This is again the solar space systems, that is, this is C is the answer, 1 and 3. Active systems and passive systems don't use any blowers, dryers and fans, blowers, heaters. In the active heating systems, we use that. Put restrictions on the building designed to make possible the flow of heat naturally. Wrong, this is. Active heating system employ mechanical devices, blowers, dryers and fans, etc., working fluid for transportation of the heat. Passive systems do not require any mechanical, make use of a natural process of convection, radiation and conduction for the transport of heat. 2 is wrong, 1 and 3 correct. In the active heating systems, we use some mechanical devices like blowers, fans, heaters, etc., coils, etc. In the passive systems, we don't use that. Naturally, we use the convection, radiation and conduction principles to heat the systems. Chemical energy. Chemical energy can be converted into the thermal energy. Electric hydrogen filled steam turbine may also be used to mechanical. D is the correct answer. Electrical energy may also be obtained more efficiently directly from hydrogen by means of a fuel cell. Yes, correct. Chemical energy can be converted into thermal energy. Hydrogen can be used as a fuel. Hydrogen has got very high calorific value. 2H2 plus O2 is 2H2 plus lot of heat, calorific value, lot of heat, thermal energy. So this can be used to generate the steam, to produce the power in a Rankine cycle. So 1 to 3, D is the correct. Solar thermal systems, A is the correct answer, 1 and 2 only. Solar energy is best suited for low grade thermal applications, because you can run a vapor absorption refrigeration system by using the solar energy. Large amount of low grade thermal energy is required for heating air for comfort. Solar energy is not utilized in the drying industry. We will utilize. Solar energy definitely utilized in the drying industries, right? He has given not. If not is not there, 3 also will be correct. So, A and 3 is wrong, 1 and 2 are correct. Solar thermal energy is utilized in drying industries. Okay. And cold climate regions, lot amount of low grade thermal energy, means by burning the coal, is required for heating the air for comfort. Temperature range is the range of temperature to which heat transporting is heated. Solar collector, it is a solar flat plate collector. 1 is correct, 1 is correct, 2 is also correct. Actually utilized in the solar flat plate collector, how much heat is actually absorbed and transferred to the heat transporting fluid? This is the solar energy. How much heat is transferred to the water here? This is a cover, flat plate, cover glass plate. This is an absorber. So, how much heat is utilized divided by how much heat energy is incident. That is called as the efficiency of the collector. Concentration ratio is the area of the receiver to the area of the aperture. Wrong actually, it is a reverse. Area of the aperture divided by area of the receiver is a concentration ratio. 1 and 2 are correct. Solar energy will be falling on the flat plate collector. It is a cover plate, glass plate, and then gets absorbed here. That will be get conducted and then convected to the water, solar water heating system, and you can generate the steam also. This is regarding the solar energy utilization. Flat plate collector, one of the desirable thermal insulating material is low thermal conductivity. Correct. Copper is often chosen by 2 is also correct. This is, see, in the absorber plate, it should have the good thermal conductivity. This glass plate should have more transmissibility. This is an absorber, right? This absorber plate should receive the solar energy and conduct that heat to the coolant, to the water circulated in the tubes. So, water will get heated up and that may become even steam and drive the turbine also as such, or solar water heating systems. Absorber plate material should have low thermal conductivity, it should have high conductivity. So, answer is 1 and 2, 3 is wrong. This absorber plate, after absorbing the solar energy, that should conduct the heat, to the coolant here. So, that see, the solar energy falls on the glass cover plate, that will transmit the energy. Most of that energy gets transmitted, and this glass plate will prevent the heat loss from the absorber plate to the air. It will stop the heat loss from the absorber to the air. So, it will only permit the energy to go one side, and that heat will get conducted and then convected. So, this absorber plate must have good thermal conductivity. Answer is 1 and 2. A. Percentage of incoming radiation is C, reflected back to the space by the earth. The sum of pressure head and potential head is a fluid mechanics, is called P by W plus Z, is called as the piezometric head. A steel wire is bent, is a strength of materials. Coming to the strength of materials, it is the bending stress. A steel wire is a circular cross section, is what is the maximum bending stress? It is now onwards, now coming to the strength of materials, very important subject in GATE. Strength of materials, you can expect 7 to 8 marks, easy, interesting, quite easy, interesting and useful for design also, another subject. So, generally when I start the GATE preparation, I advise to begin with the strength of materials in the second stream, applied mechanics and design. Very interesting, very useful subject, very interesting subject, analytical subject, mathematical subject, again necessary for doing the machine design, another important subject. Without strength of materials, you cannot do the machine design. He has asked a good number of questions in machine design and strength of materials, he has seen. That is also important in the GATE. So, strength of materials and machine design both are important in the GATE point of view and also in the engineering services point of view. This is a question on the strength of materials SOM. So, you know the bending moment equation, m by I is equal to F by Y is equal to E by R, no? This is the equation, that equation there. A steel wire, maximum bending stress will be E into Y max by R there, E by D by 2 radius of curvature into Y max will be the circular cross section. It is D by 2. D is the diameter of the wire. D by 2 will be the radius of curvature. Radius of curvature of the bending, that is. So, E into D by small d, if you put it there, you will get 50 Newton per mm square. This is a bending stress problem. This will be the radius of curvature. This will be the diameter d. D by 2 is R, that bending stress, problem on bending stress. Bending stress problem. Good question in strength of materials. Consider the following shear force and bending moment diagrams. Very important in gate point of view also. Supposing if you take a cantilever, if you take a point load here and point load here, if you draw the shear force diagram, you draw it like this, right? W1, W2. This is W1, this is W1 plus this is shear force diagram, right? So between these two things, shear force remains constant, right? Between these two point loads, the shear force between any two vertical loads will be constant, and hence shear force diagram between the two vertical loads will be horizontal. One is correct. The bending moment at the support of a simply supported beam at the free end of a cantilever will be 0. At the import simply and at the free end. In the cantilever, if you draw the cantilever here, here the bending moment diagram will be like this, right? This is the BMD. But at the fixed end of cantilever, there will be bending moment for fixing moment. Yes, 2 is also correct. The positive value of the shear force and bending moment are plotted above the base and negative values. 3 is also correct. 1, 2, 3. D is the answer. This is a cantilever, right? This is a bending moment diagram. At the point load at the free end, it will be 0. Or in the simply supported beam, also here the bending moment will be 0, right? Here the bending moment is 0, here the bending moment is 0. Shear force and bending moment diagrams for the point loads and for the uniformly distributed load for cantilever and simply supported beams, you have to learn thoroughly. The equation commonly used for finding the Darcy-Weisbach, so many times FLV square by 2GD. This is the head loss due to friction, most commonly used. Fluid mechanics. What is the expression? Again, this is a strength of materials. If there is an element, if it is subjected to the P1, and again 2 biaxial stresses, and again there is a shear, this is the Q, shear, this is the shear QXY, okay. Normal stress on any plane, normal stress will be P1 plus P2 by 2 plus P1 minus P2 by 2 cos 2 theta plus Q sin 2 theta. This is a formula that will result in the P1 cos square theta plus P2 sin square theta plus Q sine 2 theta. This is the A is the answer. This is the normal stress. This is the normal stress. This is P1. Two like unequal stresses, both are tensile and this is the shear. This is the QXY is the shear. In fact, from this only we will you will learn about the Mohr circle. This is the most general case for drawing the Mohr circle. The planes on which the shear stress is 0 are called as the principal planes, and the only normal stresses that are existing on these principal planes is called as the principal stresses, where we draw the Mohr circle, etc. No? The Mohr circle concept is very important in ESE and gate point of view. On the principal planes, there are no shear stresses. There are only normal stresses on the principal planes. Those normal stresses are called as the principal stresses. Long and is subjected to what is elongation. It is very simple question. A rod is there. It is subjected to the tensile stress. What is the P is the load, that is delta L. Change in length will be PL by AE, where L is the length there. Delta change in length will be A is the answer. One part. Just substitute that with proper units. E is the Young's modulus has been given. Young's modulus of velocity is given, but maintain proper units there. Maintain proper units. This is the elongation. No, that is Young's modulus. No, Young's modulus E is equal to shear stress by load by area is stress. Delta L by L is the longitudinal strain. This is the Young's modulus of elasticity. E or Y, sometimes they write Y, sometimes E or Y, anything is okay. Young's modulus or modulus of elasticity. It is standard strain says tensile strain, tensile stress Q is 4, shear strain R is 2, shear stress S is 1, and P will be tensile strain, P will be E. E or sometimes sigma also is the right. Not epsilon, this is right. Very standard symbols. Shear strain will be the phi. Supposing if this is a block, if you exert the shear stress like this, there will be a deformation like this, right? Block will get deformed like this. This will be the shear strain. This is a shear force. Shear force acts along the area. This will be the shear strain. Standard symbols. This is the engineering mechanics. This is the, again there are 4 marks for the engineering mechanics in gate. It is a straight question. Displacement has been given for a rectilinear motion. For a particle to reach from its initial condition at t is equal to 0, position coordinate which is configured. Position coordinate is S, no? S is there, and what is the velocity? Velocity is equal to rate of change of displacement. 60 square minus 24 put. V is equal to 72. 72 is equal to 60 square minus 24. T will be 4 seconds. A is the answer. Straight question. Simple engineering mechanics question. To get the velocity of 72 meters per second, how much time will be taken? Velocity is rate of change of displacement. Here if you want to get the acceleration, acceleration will be dv by dt. This is 12t. That means it is a variable acceleration. It is not uniform motion. Not uniform motion. Not uniform, that means not, it is a variable acceleration. You can't write that v square minus u square is equal to 2as, s is equal to ut plus half at square. We cannot write it because it is a variable acceleration. Those equations are for the constant acceleration. It is a semicircular area. It is a moment of inertia. Sorry, centroid. It is a problem of the centroid. Centroid, right? It is 4r by 3 pi. Semicircular, triangular it is h by 3 from the base, and the rectangular b by 2 or h by 2 if h is there, no, rectangular moment of centroid, this is a centroid C, h by 2, and again we have the parabolic will be 4r by 3 pi, 4r by 3 pi for the parabola. Accordingly you can write, this is the triangle h by 3, 4r by, no sorry 3b by 8, parabola 4r by 3 pi, no 3b by 8, sorry 3b by 8. Parabola. Semicircular is 4r by 3 pi. Centroid. Limiting friction, F is equal to mu into Rn. Limiting force of friction. F is called coefficient of friction. Pairs a constant ratio to the normal reaction between the two sources. This is the law of friction. Is always greater when the two surfaces are in motion. Wrong. 2 is wrong. Why? Mu of the K kinetic friction is lesser than the mu of the static friction. Okay, limiting frictional force do not depend upon the area of contact. This is the law of friction. Limiting force of friction is directly proportional to the normal reaction, where mu is the coefficient of friction. Coefficient of kinetic friction is lesser than the coefficient of static friction. That is why ratio between this mu value is always greater when the two surfaces are in motion. Wrong statement. Mu value is lesser when the bodies are in motion. See, coefficient of kinetic friction is lesser than the coefficient of static friction. You have learned in the 11th class also. And the coefficient limiting force of friction does not depend upon the shape and area of contact. Yes, correct. It depends only on the normal reaction, does not depend upon the area of contact, shape of the surfaces, etc. So, 1 and 3 are correct, does not depend, limiting force of friction does not depend upon the area of contact. Answer is 1 and 3, C is the answer. Simple questions, very simple questions you have based on the physics you have learnt in 11th class. What is the magnitude of the third force P? 3 forces are there, collinear forces. This is the x-axis, this is the y-axis. 3 forces, 40 kilonewtons is 60 degrees. This is 40 kilonewtons, 60. 15 kilonewtons at 120. At 120, 15 kilonewtons. And 240 here. This is the unknown force P. This is x-axis. This is the y-axis. 40, 15 P. And the resultant at 85. This is the resultant. This is the resultant at 85.28 degrees. This is the result. Then what is the P? Very simple. The algebraic sum of all the x direction component, algebraic sum of all x direction components must be equal to the component of resultant or along x. Simple thing. That is 40 cos 60 plus 15 cos 120 plus P, how much is equal? Cos 240 should be equal to the resultant, no, R is how much? Resultant R. R R cos 85.28. R has been given. R is equal to, is given 30.41. You will calculate P. You will calculate P as 20 kilonewtons. Simple question. Take the component of all the forces along the x. That is for the 40, P and 15. Then get the component of the R along the x. Equate both. Algebraic sum of all the x direction components should be equal to the component of R along x. You will get P as 20. Simple engineering mechanics question. Impact strength increases if the dimensions of the specimen are increased. One is correct. When the notch, it is an impact strength notch. When the second one is wrong. The angle of notch also improves the impact strength of certain values. Yes, correct. B is the answer. There is this V notch, impact. This all depends upon the impact increases if the dimensions of the specimen are increased. Yes, definitely that depends upon the dimensions of the V notch. When the sharpness of the increases, impact strength of the material required to cause the failure also increases. Sharpness, this angle, angle of notch also improves the impact strength of certain values. A maximum, it will have the 60 degrees, you will have the maximum. Increases the impact strength of the material required to cause the failure. That here, this point, this point, the sharpness decides this point there. So answer will be 1 and 3. Answer will be 1 and 3. See there. 2 is wrong. When the sharpness of the increases, when the sharpness decreases, impact strength will be required also increases there. So that second one is wrong. Second statement is wrong. 1 and 3 are correct. B, sorry. 1 and 3. C is the answer. Second one is wrong statement. This is the impact strength pertaining to the V notch. This is a straight question. This is E is equal to 3K into 1 minus 2 nu, 1 minus 2 by M. You just get that answer. E is equal to, C is equal to, this is the K is the bulk modulus, E is Young's modulus. E is equal to 2C into 1 plus nu, 1 plus 1 by M, where nu is the Poisson's ratio. E is equal to 9Kc by 3K plus C. These are the relations among the elastic constants. K is the bulk modulus, C is the shear modulus, E is the Young's modulus. Remember them. In the strength of materials, simple stresses and strains, the K is bulk modulus, E is Young's modulus, and C is the shear modulus. 61 question will be physical isotropic means are dependent. Isotrope if you are not dependent on them. P is 1. Anisotropic means variation will be there. Ductility. What is the ductility? The ability of the material to get elongated into wires, thin wires. The property of which governs its ability to be deformed in processes. Ductility means the ability of the material to get elongated into thin wires. Steel is a ductile material. If you elongate it, it gets elongated. It won't break. To thin wires, you can elongate it. Cold working is a plastic deformation at a temperature above the, no, it is below. One is wrong. It is not above, it would be below. Hard working at such temperature, recovery and recrystallization, 2 is right, 3 is also right. With the strain hardening, hot working and cold working. No? Refractoriness. it should be withstand the refractory means high temperatures may withstand, permeability, cohesiveness, ability of the sands to other bodies. This is the A is the answer. Adhesive, sorry, this is not correct. Adhesive means ability of these two other bodies to stick together. Cohesiveness is this. Refractoriness is this. Refractory means to withstand the high temperature. Refractory bricks they called. They can withstand the high temperatures. These are casting sand. This is only one question asked in the casting. Generally, in the production part, particularly ESE, they didn't ask a much number there. But in GATE, they asked 16, 17 out of the 24 marks, 25 marks of the third stream, 16 marks they asked casting, forming, welding, metal cutting, machining, and all these metrology, instrumentation. They ask a good number of questions. Here they are not asked much. On this casting, usually they ask 2 marks in GATE. Here there is only 1 mark question they asked. Answer is A. Casting sand properties. Permeability means ability to allow the gases. Permeable means gases can be allowed to pass through it. Slam is 1, 2, 3. The slam forms the answer is 1, 2, 3. It is regarding the mechatronics. A is the answer. 56 is A. All these questions are regarding the mechatronics. 55 is also A. All these questions on the mechatronics. Mechatronics and control systems, that is. '53 is also A. Electroencephalograph. '52 is C. Regarding the intrinsic tactile sensing. 51 is D. Actuators. Regarding the question regarding the actuators, and actually actuators are the very important components in the mechatronics. It is a communication pattern. '49 will be D. 48 will be D again. 47 is, see, it's how much voltage, but usually fuel cell, how much voltage means C. Typical at a full rated load, 0.6 volts to the 0.7. C is the answer. Mechatronics and robots, answer will be C. All robots are not mechatronics. They are all mechatronics only. All robots are mechatronics, but all mechatronic systems are not robots. It's the other way around. 2 is wrong. See, at elevated temperatures, determine the continuing changes in the deformation. That means creep test. D is the answer. At elevated temperatures, which of the following tests is used to determine the continuing changes in the deformation at elevated temperatures? Answer will be D, creep test. '44 is D, nanomaterials. This question is nanostructured materials. It is all regarding the material science. All these questions are molybdenum, tungsten, titanium. For non-ferrous alloys, it is all the material science. Grey cast iron, ductile cast iron, malleable cast iron. All these questions are pertaining to the material science. This is A. Answer is A. Material science has asked almost 10 questions here in ESE, but in GATE only one question may come and may not come on this material science. 41 is C. There is a low stainless steels are there, low alloy ferrous alloys are there, high alloy ferrous alloys also there. Stainless steels, you got two kinds of the stainless steels. You got a low alloy ferrous alloys and high alloy ferrous alloys. Heat treatment known as tempering. This is ductility and toughness. What is the toughness? The ability of the material to store the energy is called toughness. Ductility is the ability of the material to get elongated into thin wires. Okay. Whereas toughness is the ability of the material to absorb and store the energy. That is why proof resilience and that is all connected to the toughness property. Resilience, proof resilience. 39 is B, terminal solid solutions. This is also regarding the material science. 38 is A. (37) is A again. It is a FCC, BCC structure metallurgy. 36 is total how many atoms may be assigned to a given unit cell. The formula will be Nc by 8 plus Nf by 2 Ni by 1, that is 8 by 8 plus 6 by 2 plus 0 by 1, that comes to 4. B is the answer. This is Ni is here is 0, Ni by 1, this is Ni by 1, this is Ni is 0, 0 by 1, it will become 4. This is a theory of machines question, answer is C, theory of machines. Balancing. The area under the turning moment diagram represents work done per cycle, correct? The dividing the area of the turning moment diagram with the length of the base gives the mean turning moment, that is also correct. The maximum ordinate of the turning moment diagram, turning moment diagram versus crank angle. Governing flywheel, is a flywheel questions that. Maximum ordinate of the turning moment diagram gives the maximum torque. Crankshaft is subjected to, right, correct. All the three are correct. Answer is D. This is a question on flywheel theory of machines. 33. It is the answer is do not anyway affect the velocity ratio in a simple gear train, intermediate gear train or idle gear. Idler gear. Intermediate gear or idler gear, B is the answer. This is also gears regarding the theory of machines. What is the name of the gear, half of which it is a herringbone gear or double helical gear? The angle of approach, it is a gear design, answer will be A. Regarding the A, that is 1 and 2 only. It is not necessarily. Third is not necessarily correct. Not necessary condition. Here this is the which theory is the failures of you got Coulomb theory, Tresca's theory, Guest theory, Hay theory, out of which Rankine theory is applicable for the brittle materials where the ultimate strength is maximum principal stress theory. This is called as the maximum principal stress theory, which is applicable for the brittle materials where the generally other theories of failure will consider the yield strength, here we consider the ultimate strength. Rankine's theory is applicable for the brittle materials, answer is A. Generally theories of failure are very important in GATE, and as here he has asked von Mises. In GATE 2025, he has asked the von Mises criteria, theories of failure. So, questions on theories of failure are very important in both ESE and particularly more important GATE point of view. Strength is the ability of the material to resist and with and without rupture, correct. Elasticity is defined as the ability of the material to regain its original shape and size after the deformation. What is an elastic property? Your load is applied, material get elongated. If they remove the load, the material would be able to regain its original shape and size. So 2 is also correct. Plasticity is defined as the ability of the material to retain deformation. Plastic material means when you apply the load, material would get elongated. When you remove the load, the material would not be able to come to its original size. Whatever the deformation it has got, it would be able to retain that. That property is called as plasticity. 1, 2, 3, all the 3 are correct. 2 plates subjected is a machine design problem. It is a machine design. It is a lap joint, taking this as a lap joint. Riveted design of the riveted joints. Load on each will be 3, load divided by area should be less than the single lap joint. You will get the DS 20.60 mm. Straight question. There are 3 rivets. This is the load on each rivet. This is the stress should be less than the permissible shear stress. This is 50. Load on the 3 rivets are there, load divided by 3, that load on each rivet divided by area. This is a single lap joint, not the double lap joint, single lap joint is taken. Ergonomics, yes, is a relationship between man and the machine. One is correct. Ergonomics is the natural laws of what at work. Ergonomics have not carried out experiment to determine the best dimensions of a driver seat. We will consider. Not carried out means it has carried out. 3 is wrong. 1 and 2 only. When you are designing the driver seat, your spine shape and how much at what length the hand should be kept, everything should be taken into account. That particular topic is called as the ergonomics. Between the man and machine, there must be compatibility, keeping the human body and its human body has got certain limitations, certain stresses it is subjected to. Taking that into account, if you design the machine and its handling, that subject is called as the ergonomics. Bearing is used to support the rotating shaft and confine its motion. Key is used to, 1 and 2, 1 is correct. Key is used to transmit the torque between the shafts. Power screw is used to store. It is not a store there. Power is, like a power screw is meant for connecting, power screw, that is 3 is wrong. It is not meant for storing. 1 and 2 only. It is also a machine design. Time or frequency, vibrations. Vibrations questions are also important in the gate point of view. In the gate, in a vibration, every vibrating motion, what is more important, time or the frequency, right? In any vibration, most important parameters are time and the frequency. How fast the things are vibrating. 24 will be C. It is a industrial engineering. the shape, no, that is regarding the bathtub. In the reliability engineering, reliability management, all the three are correct. These are industrial management, industrial engineering. Here the C is the correct answer. This is the inventory. This is a question on inventory, inventory control. 21 will be A, PET CPM. It is a question on PET CPM, critical path method, program evaluation review technique. This is the question is dummy activity. 20th will be D, material requirements and planning. It is a production planning and control, PPC of the industrial management. It is again layout, material handling. 18 will be sign bar usage in angle measurement. It will be B, metrology and instrumentation, metrology. '17 will be B. This is a fits and clearances, production, fits and clearances, answer will be B. Only one question is asked in the metal cutting. The cutting tools due to addition of the tungsten and again material science, it is a hardness. When you use the molybdenum and tungsten to the high carbon steel, hardness will be increased. Critical speed at which the shaft starts to vibrate violently in a transverse direction, B. Shaft to vibrate in this transverse direction. This is a shaft will rotating, that is the critical speed, vibrate violently in this transverse direction, that is called as the, this is critical damping, A is the answer. Damping ratio. 13th question will be C. Base circle, it is the smallest circle drawn to the pitch curve from the center of, this is the pitch circle. Base circle will be the 3, P is 3. It is the smallest circle that can be drawn to the cam profile. In the cams, in the cam and follower mechanism, prime circle. These are the, in the cam and follower, there very, in the gear trains formula to be remembered is more, but in the cams and followers, hardly 4 or 5 formula will be there. It is easy to remember them. Answer will be C. It is a cam and follower mechanisms, the theory of machines. For a pivoted or pin joint, the instantaneous centers, one is right. For a pure rolling of the two links, the instant lies at their point of contact. 2 is also correct. 3 is in a sliding motion, instantaneous center is lies at infinitely direction. Because when a body is sliding, its instantaneous motion will lie at an infinite distance. In a sliding motion, it's because its radius of curvature is at infinite there. 1, 2, 3 all are correct. Instant lies at their point of cut. In a pure rolling motion, the instantaneous lies at their point of contact. For a pivoted pin joint, instantaneous for the two links lies on the center of the pin. This is the first one. This is the second one. For this is the third one. All three are right. For a body in sliding motion, its instantaneous center lies at an infinite radius. This distance will be infinity. 11th one will be inversion of the mechanism. Kinematic chain means that if by fixing one link, you will get 111 inversion of the mechanism. Most common thing is a slider crank mechanism. This is again a power plant. Condenser without extraction pump. There are certain condensers which do not require any air extraction pumps. Best example is barometric condenser. The tail, the tail of that condenser, will provide the necessary head to extract the condenser. It is called as the barometric condenser. Barometric condenser do not require any air extraction pump. Other things will require the air extraction pumps. Ninth question is the number of single degree of pairs and 2 degree of pairs there. This is a higher pair. This is the higher pair. 2 degree of freedom pairs means higher pair. So answer will be A here. What is the addendum there? 8th question. The height of the tooth above the pitch circle is the addendum. Basic definitions only as asked. Resilience is defined as the ability of the material to absorb energy elastically and to release this energy when unloaded. Yes, that is why it is a proof resilience and all that. 1 is correct, 2 is wrong. Increased by increasing its length, because strain energy is directly proportional to the volume, the strain energy. When you increase the length of the bolt, volume will be increased. Obviously, that resilience also will increase. 2 is wrong. So 1 and 3, C is the correct answer. A cylindrical pressure vessel. This is a cylindrical pressure vessel. This is the pressure acting. Pressure into area will give the number of the rivets into permissible stress. Permissible, that is pressure is how much given? Pressure is 1.5 into 10 cube into pi by 4 d square, where d is the pi by 4 d square, where d is the diameter of the pressure vessel. N into pi by 4, what is the diameter of the bolt, diameter of the rivet? 23 by, take care of the units there, and sigma will be 60. We can keep this in mm there also, there 23 there. Take care of the units there, N will be 48. This is the force, pressure into area. There should be number of rivets into that pi by 4 d square. We can maintain a proper units there. You can keep the diameter also in mm there. Diameter of the internal diameter, you can keep this as 1000. You can keep everything, you can maintain in mm. You will get the, so that you can keep this in mm, you can keep this also in mm there. So you will get the N will be, because 60 is also given in Newton per mm square. But here it is given in MPa, therefore 10 power 6 it will become, because 1 megapascal is 1 pascal is 1 Newton per meter square. Okay, 1.5, take care of the units then, 1 Newton per meter square it will become, but again you have to convert into the mm square. Otherwise you put the d into 1 meter there, and this one you keep it in 1000. Yes, put the d in 1 meter only. Everything you put it in meters there, then you will get the we maintain proper units. This is the stress into area will give the load taken by each rivet into number of rivets. This is a pressure into area it will be the total force. This is the area of cross section, right? That is pi by 4 d square. We can keep 1 meter there. This is the welded joint mission design problem. It is a Bhandari, tried question from Bhandari textbook. Directly it is taken from, you can open the mission design by Bhandari, you will see this question. Load is equal to, these two are taken shear and this is transverse. 0.707 into 75 into 10 into 70 plus 2 into 0.707 into length into thickness into 50. You will get certain length, add 15, you will get exactly 40.29 mm. This is taken as, one is taken as the, these two taken as the shear stresses. Generally everything should be taken as shear if nothing is mentioned, but this part is taken as the tension, these two parts are taken in shear. That is why these two things are taken as the shear stresses and the this is taken as the under the tension there. That is why this is taken there, 70 there, tensile stress has been taken there. Answer will be A. This is questions on the fatigue there. Fourth question, answer will be 1 and 2. This is a question on fatigue. Fatigue means, actually basically fatigue means cyclic stresses. Fatigue is connected to the cyclic stresses, time bound. Whenever any member is subjected to a cyclic stresses, that means stress is increasing, decreasing, increasing, decreasing. There is a cycle. How rapidly the stress is increasing and decreasing, that will again decide the how quickly the material will yield actually. Because more the cycle, definitely that there will be a more chance for the member to fail. So fatigue is the stress connected to the cyclic variation of the loads. Look at this, the surface scratches serve as the stress risers and result in stress concentration. Here the 1 and 2 are the correct. Since the fatigue test cannot be conducted in unlimited, 10 power cycles are considered 10 to the power of cycles, sufficient number of cycles to define the endurance limit. 1 is correct. Defined as the number of stress cycles that the standard specimen come during the test before the appearance of the first fatigue crack. Yes. Second is also correct. SN curve, stress versus, this SN curve is a graphical stress amplitude versus number of stress cycles before the fatigue failure and a log graph paper. 3 is also correct. See, with the time, if the stress is varying with time, how quickly it is varying, that really matters in deciding the failure of the member. If the stress is varying, any cyclic things are happening there, stress is rapidly changing from positive to negative, etc., definitely the member is liable to fail. So that is connected to the endurance limit. All the 3 are correct here. There are 3 questions on the fatigue in this paper. The second question is also this one is also D, correct. D is the answer. Fatigue failure is defined as a time delayed fracture under cyclic loading. Cyclic loading means load is increasing, decreasing, increasing, decreasing with the time, changing. Load is changing with time. Very rapidly changing means the member is liable to fail quickly. It begins with a crack at some point in the material. Fatigue cracks are not visible till they reach the surface of the component. By the time the failure has already taken place. Fatigue is a failure. Fatigue failure is the failure of the member due to the cyclic variation in the load with respect to the time. As the time varies, the load keeps changing. In a little amount of time, if the load is changing very rapidly, that means there is a more fatigue. The member is liable to undergo fracture or undergo failure. Even before the failure comes to the surface, already the crack has begun. fatigue cracks are inside. By the time they come to the surface, already it has, member is already subjected to the fatigue. Answer will be D. Here this higher calorific value, HCV, is calculated from Dulong's formula. Actually, calorific value is the amount of heat liberated when 1 kg of the fuel undergoes complete combustion, right? When 1 kg of the fuel undergoes complete combustion, how much heat is liberated? It is a calorific value. Why there are two calorific values? HCV, any fuel has the hydrogen, any fuel has got hydrogen. 2H2 plus O2 is 2H2O plus heat. Whatever the water vapor that has been there in the products of combustion, if they are cooled to the room temperature, they liberate some latent heat of condensation. If that heat is also accounted in the as the total heat liberated, that is called as a higher calorific value. What is lower calorific value? We do not cool the products of combustion to the room temperature. We just evaluate whatever the heat liberated by the 1 kg of the fuel combustion. If that heat is evaluated, it is called as a lower calorific value. LCV is the amount of heat liberated when 1 kg of the fuel undergoes combustion, complete combustion, and without cooling the products of combustion to the room temperature, we just evaluate what is the heat liberated, that is called as the lower calorific value. In the higher calorific value, what we do is we will cool the products of combustion down to the room temperature, and then what is the heat evolved, we calculate that, that is called as the higher calorific value. When you are cooling the products of combustion, this water vapor will condense and liberates latent heat of condensation. So, I can say the difference between the HCV and LCV, HCV minus LCV is the latent heat of condensation, of water vapor formed due to combustion of hydrogen, So that is it. Suppose if the fuel has no hydrogen, if the fuel has got no hydrogen, then there is no difference between the HCV and the LCV. Bomb calorimeter measures the HCV of coal. Bomb calorimeter measures HCV. Junker's gas calorimeter will measure the LCV of the gaseous fuels. Junker's gas calorimeter. Bomb calorimeter measures the HCV of the solid fuels like coal, solid fuels like coal. For the measuring the HCV, the Dulong's formula is used. So, fuels and combustion has asked one question. So, most of the questions if you see in the ESE 2025, majority are asked in the power plant. Mainly they are asked in the power plant. Strength of materials not many, engineering mechanics not many. But in gate point of view, strength of materials, engineering mechanics and machine design and theory of machines, they play a vital role along with the thermodynamics, fluid mechanics, heat transfer and applied thermodynamics. Power plant, in the ESE power plant will play a major role. Power plant, very good number of questions, and also the some of the questions from the mechatronics, robotics, which are not there in the gate syllabus. Overall, I will rate the paper as moderate to easy. As compared to the last year, the cutoff mark may rise. As compared to the 2024, the cutoff mark may rise in this year prelims size. So, with this, I would like to conclude the paper analysis. This is Sekhar from Msigma Gokulam. Any doubts if you have, you may reach out to me on this mobile number 98494 10269. We have the WhatsApp groups. Also, we can put it in that WhatsApp groups, anything doubts regarding this paper analysis or whatever it is there. So, this paper I would rate it as the moderate to easy. So, with this I would like to conclude the paper analysis of the ESE and wish you all the best for your mains paper. Those whoever is appearing for the ESE mains. Mains will be, in fact, it will be a time taking, but give some more important to certain areas like power plant. One question will be like Shraddha materials. One solid question will come for 20-25 marks. Heat transfer, one solid question may come from for 15 to 20, design of a condenser or a design of a heat exchanger like that. So, certain areas will play definitely a very important role, certain pockets of the subjects where the 15 to 20 marks questions will definitely come in the ESE mains. Wish you all the best for the mains. Good luck.